Staring into the vast expanse of the cosmos, it's easy to feel small, insignificant even. But what if I told you that beyond the stars and galaxies we can see, there's a boundary, a place where the known universe seems to end? What lies beyond that edge? Is it an infinite void, or could there be something even more extraordinary waiting to be discovered? Today, we're diving into the cutting-edge theories and mind-bending predictions that scientists are exploring about the edge of the universe. From parallel realities to the mysterious forces that shape existence itself, we'll uncover what might be lurking in the farthest reaches of space. This isn't just about what we know, it's about what we don't know, and the possibilities that could redefine everything we think we understand about reality. So, are you ready to explore the edge of the cosmos? Let's begin. The observable universe is a staggering 93 billion light-years across, a scale so vast it's almost impossible to wrap our minds around. But here's the twist, that's just the part we can see. Beyond this cosmic horizon lies a mystery that challenges our understanding of space, time, and reality itself. Scientists believe the universe is expanding, and not just at a slow, steady pace, it's accelerating faster than the speed of light. This means the very edge of what we can observe is constantly being pushed further away, like a horizon that always stays just out of reach. It's as if the universe is playing a cosmic game of hide and seek, keeping its deepest secrets locked away. So, what exactly is this cosmic horizon? Think of it like standing on a vast, open plain. No matter how far you look, there's a point where the Earth curves away, hiding what lies beyond. In the same way, the cosmic horizon marks the limit of what we can observe, not because there's nothing beyond it, but because the light from those distant regions hasn't had enough time to reach us. And here's the kicker, because the universe is expanding faster than light can travel, some parts of it may forever remain invisible to us. It's a humbling reminder of just how much of the cosmos might be hidden from our view. But how do we even know where this boundary lies? One of the key tools scientists use is the cosmic microwave background radiation, a faint glow left over from the Big Bang. This ancient light, which has been traveling for over 13 billion years, acts like a cosmic map, showing us the structure of the early universe. By studying it, we can trace the edges of the observable universe and piece together the story of how it all began. Yet, even with this incredible tool, the cosmic microwave background only reveals so much. It's like trying to read a book with half the pages missing. We can make educated guesses, but the full story remains tantalizingly out of reach. Which brings us to the big question, could there be more to the cosmos than what we can observe? Some theories suggest that the universe might be far larger, or even infinite, stretching far beyond what we can detect. Others propose that our observable universe might be just one bubble in a vast multiverse, where countless other universes exist alongside ours. The truth is, we may never know for sure, but that's the beauty of science. It's not just about finding answers. It's about exploring the unknown, pushing the boundaries of what we think is possible, and daring to ask the questions that challenge everything we thought we understood. At the heart of the universe's accelerating expansion lies one of the greatest mysteries in modern science, dark energy. This invisible force, which makes up about 68% of the universe, is pushing galaxies apart at ever-increasing speeds. But what exactly is dark energy, and why does it seem to have such a profound, almost unstoppable influence on the cosmos? The story of its discovery begins in the late 1990s, when astronomers studying distant supernova made a startling observation. These exploding stars were fainter than expected, suggesting they were farther away than previously thought. The only explanation, the universe wasn't just expanding, it was speeding up. And dark energy was the culprit behind this cosmic acceleration. The implications of dark energy are as profound as they are puzzling. if it continues to dominate the universe, it could shape the ultimate fate of everything we know. One of the most dramatic possibilities is something called the Big Rip. Picture this: as dark energy grows stronger over time, it could eventually overcome the forces holding galaxies, stars, and even atoms together. In this scenario, the universe wouldn't just expand, it would tear itself apart, fragmenting into isolated particles drifting in an infinite void. It's a chilling thought, but one that scientists take seriously as they try to unravel the nature of this mysterious force. Yet, despite its name, dark energy isn't inherently destructive. In fact, without it, the universe as we know it might not exist. Dark energy's role in accelerating expansion could be the very reason galaxies formed and life emerged in the first place. It's a delicate balance: too much dark energy, and the universe rips itself apart; too little, and it might collapse back in on itself. This balance raises another intriguing question. Could dark energy hold the key to understanding the edge of the cosmos? If it's responsible for pushing the boundaries of the observable universe ever outward, then studying it might help us glimpse what lies beyond those limits. But here's the catch: we still don't know what dark energy actually is. Some theories suggest it's a property of space itself, a kind of cosmic background energy that permeates the universe. Others propose it could be tied to new, undiscovered particles or fields. And then there's the possibility that our current understanding of gravity might be incomplete, requiring a complete rethink of the laws that govern the cosmos. Each of these ideas brings us closer to the edge of what we know and pushes us further into the unknown. What makes dark energy so fascinating isn't just the questions it answers, but the ones it raises. Why does it exist? Is it constant, or could it change over time? And what does its presence mean for the ultimate fate of the universe? These are questions that keep scientists awake at night, driving them to build ever more sensitive instruments and explore ever more distant corners of the cosmos. Dark energy isn't just a mystery, it's a reminder that the universe is far stranger and far more wondrous than we ever imagined. And as we continue to probe its secrets, we're not just exploring the edge of the cosmos, we're exploring the very limits of human understanding. So, if the edge of our universe is shrouded in mystery, what lies beyond it? Could there be other universes out there, each with its own rules, its own stars, and maybe even its own version of you? This isn't just science fiction, it's a serious scientific idea known as the multiverse theory. At its core, the multiverse suggests that our universe might be just one bubble in a vast cosmic foam, where countless other universes exist alongside ours, each with its own unique laws of physics. Some could be eerily similar to ours, while others might be so different that they're almost unrecognizable. The idea is as thrilling as it is mind-bending, and it's rooted in some of the most cutting-edge science we have today. One of the key pieces of evidence supporting the multiverse comes from quantum mechanics, the branch of physics that deals with the smallest particles in existence. In the quantum world, particles don't behave like the objects we're used to. Instead, they exist in a haze of possibilities where multiple outcomes can happen simultaneously. This phenomenon, known as superposition, has led some scientists to propose that every possible outcome actually happens but in a different universe. For example, if you flip a coin, one universe might see it land on heads while another sees tails. It's a strange idea, but it's one that helps explain some of the quirks of quantum mechanics. And if it's true, the multiverse could be teeming with infinite versions of reality, each playing out its own unique story. String theory takes the multiverse concept even further. According to this framework, the fundamental building blocks of the universe aren't particles but tiny, vibrating strings. These strings can exist in multiple dimensions, far more than the three we're familiar with. Some versions of string theory suggest that these extra dimensions could house other universes, each separated by a thin membrane of space-time. Imagine our universe as a sheet of paper floating in a stack of countless other sheets. Each sheet represents a different universe with its own laws of physics, its own history, and its own potential for life. The edge of our cosmos, then, might not be the end of everything. It could be the beginning of something even bigger. But how could we ever know if these parallel universes actually exist? The answer lies in the search for subtle clues, like ripples in the cosmic microwave background or anomalies in the distribution of galaxies. Some scientists believe that collisions between our universe and others might leave behind detectable imprints like cosmic fingerprints. Others are exploring the possibility of gravitational waves, ripples in space-time, that could carry echoes of other universes. These are incredibly faint signals, but with advances in technology, we might one day find the evidence we've been searching for. The implications of the multiverse are staggering. If there are infinite universes, then somewhere out there, every possible version of reality exists. There could be a universe where dinosaurs never went extinct, or one where you made a different life choice that changed everything. It's a concept that challenges our understanding of identity, destiny, and even the nature of existence itself. And while it's easy to get lost in the enormity of it all, the multiverse also reminds us of something profound. The universe or universes are far stranger and more complex than we ever imagined. So as we stand at the edge of our observable cosmos, peering into the unknown, we're left with more questions than answers. Are we truly alone, or are we just one thread in an infinite cosmic tapestry? The multiverse theory doesn't just expand our horizons, it shatters them, inviting us to imagine a reality where the possibilities are truly endless. And perhaps in that vast expanse of universes, the greatest discovery of all is the realization that there's still so much left to explore. If the multiverse theory stretches our imaginations, the Big Freeze brings us back to a more sobering reality. Imagine a universe where stars burn out, galaxies drift apart, and the cosmos grows colder and darker with each passing eon. This isn't the dramatic explosion or collapse you might expect. It's a slow, quiet fade into nothingness. Known as the Big Freeze or heat death, it's one of the most widely accepted predictions for how our universe might end. But what does this chilling scenario actually mean, and how does it connect to the edge of the cosmos? To understand the Big Freeze, we need to start with entropy, a measure of disorder in the universe. Over time, entropy naturally increases, meaning energy becomes more evenly distributed. Think of it like a cup of hot coffee left on the counter. Eventually, the heat spreads out and the coffee cools to room temperature. In the same way, the universe is constantly spreading its energy, becoming more uniform and less dynamic. As this process continues, stars will exhaust their fuel, galaxies will grow farther apart, and the universe will become a vast, cold expanse where no new structures can form. But here's where it gets even more fascinating and unsettling. The Big Freeze isn't just about temperature, it's about the loss of usable energy. In a universe where everything is evenly distributed, there's no difference in energy levels to drive processes like star formation, chemical reactions, or even life itself. It's a state of equilibrium where nothing changes because there's no energy gradient left to fuel change. The universe, in effect, becomes a cosmic graveyard, frozen in time and devoid of activity. So, what does this mean for the edge of the cosmos? If the Big Freeze is our ultimate fate, then the expansion of the universe plays a critical role. As dark energy continues to push galaxies apart, the space between them grows, and the universe becomes increasingly empty. The edge of what we can observe today will eventually stretch so far that even light from distant objects won't reach us. Over unimaginable timescales, the observable universe will shrink, isolating any remaining pockets of matter and energy. It's a lonely, chilling vision of the future, one where the cosmos itself fades into silence. But is this truly inevitable? While the Big Freeze is a compelling prediction, it's not the only possibility. Some scientists suggest that dark energy, the very force driving the universe's expansion, could change over time. If it weakens, the expansion might slow, potentially allowing gravity to pull matter back together in a cosmic reversal. Alternatively, if dark energy strengthens, it could lead to the Big Rip, a scenario where the universe tears itself apart long before the Big Freeze can take hold. These competing theories remind us that the universe's fate is far from settled. The Big Freeze also raises profound questions about the nature of existence itself. If the universe is destined to end in cold, lifeless stillness, what does that mean for us? Are we just temporary flickers of light in an otherwise dark and indifferent cosmos? Or is there something more to our existence that transcends the physical limits of the universe? These questions might not have clear answers, but they invite us to reflect on our place in the grand tapestry of reality. As we contemplate the Big Freeze, it's worth remembering that this scenario is still a prediction, one based on our current understanding of physics. The universe has a way of surprising us, and there's always the possibility that new discoveries could rewrite the story of its fate. Whether the cosmos ends in a cold, quiet fade or something entirely unexpected, the journey to uncover its secrets is far from over. And as we peer into the vast unknown, we're reminded that the universe is not just a place of endings, it's a place of endless wonder. While the Big Freeze paints a picture of a cold, lifeless end, there's another possibility that flips the script entirely: the Big Crunch. Imagine, instead of fading into darkness, the universe collapsing back in on itself, like a cosmic inhale after an unimaginably long exhale. This theory suggests that gravity, the force that pulls everything together, might one day overpower dark energy, the force pushing everything apart. If that happens, the universe wouldn't just stop expanding. It would reverse course, hurtling toward a fiery, dramatic conclusion. But here's the twist: the Big Crunch might not be the end. It could be the beginning of something entirely new. To understand how this could happen, let's revisit the tug of war between dark energy and gravity. Right now, dark energy is winning, driving the universe's accelerating expansion. But what if that changes? Some theories suggest that dark energy isn't a constant force, it could weaken over time. If it does, gravity could regain the upper hand, pulling galaxies, stars, and even space itself back together. The result, a universe that contracts, growing denser and hotter until it collapses into a single, unimaginably tiny point. This is the essence of the Big Crunch, a cosmic reversal that would rewrite the fate of everything we know. But the Big Crunch isn't just about destruction. For some scientists, it's a gateway to rebirth. If the universe contracts into a single point, it could trigger another Big Bang, setting off a new cycle of expansion and contraction. This idea, known as the Cyclic universe theory, suggests that our universe might be just one in an endless series, each ending with a Big Crunch and beginning with a Big Bang. It's a cosmic dance of creation and destruction, where the edge of one universe becomes the starting point for another. What would this look like? Picture the universe shrinking, galaxies merging as they're drawn closer together. Stars would burn brighter and hotter, their light growing more intense as the cosmos contracts. Eventually, everything matter, energy, even space-time itself, would be compressed into a singularity, a point of infinite density. And then, in a flash of unimaginable energy, a new universe could burst forth, born from the ashes of the old one. It's a vision that's both terrifying and awe-inspiring, offering a sense of continuity in an otherwise chaotic cosmos. But is this cyclical model plausible? The answer lies in the balance of forces. For the Big Crunch to occur, gravity would need to overcome dark energy, something we don't currently observe. However, our understanding of these forces is still evolving. Dark energy remains one of the greatest mysteries in science, and its behavior over time could hold the key to the universe's fate. Some theories even suggest that dark energy could fluctuate, weakening enough to allow gravity to take control. If that happens, the Big Crunch could become more than just a theory, it could be our future. The idea of a cyclical universe also raises profound questions about time and existence. If the universe goes through endless cycles of birth, death, and rebirth, does time have a beginning or an end? Or is it an eternal loop where each cycle is both a conclusion and a new beginning? These questions challenge our understanding of reality, blurring the line between science and philosophy. They remind us that the universe is not just a place of physical laws, it's a canvas for some of the deepest mysteries of existence. And what about the edge of the cosmos in this scenario? If the Big Crunch leads to a new Big Bang, then the edge of our universe might not be a boundary at all, it could be a bridge. A place where one universe ends and another begins, where the laws of physics reset and the story starts anew. It's a concept that transforms the edge from a final frontier into a cosmic crossroads, a point of infinite possibilities. The Big Crunch offers a radically different vision of the universe's fate, one that's as much about renewal as it is about destruction. It challenges us to think beyond the end, to imagine a cosmos where nothing is truly lost and everything is part of an eternal cycle. Whether this theory proves true or not, it reminds us that the universe is full of surprises and the story of its fate is far from over. So, as we stand on the edge of what we know, peering into the unknown, we're left with a tantalizing question. Could the end of our universe be the beginning of another? The story of the universe's birth is as dramatic as it is mysterious. In the first moments after the Big Bang, something extraordinary happened, a burst of expansion so rapid and intense that it defies imagination. This phenomenon, known as cosmic inflation, saw the universe grow exponentially in a fraction of a second. To put it in perspective, imagine a tiny speck of space suddenly ballooning to the size of a galaxy. And then, just as quickly, the expansion slowed, leaving behind the seeds of everything we see today. But what caused this incredible growth spurt, and how did it shape the cosmos we inhabit now? Cosmic inflation isn't just a fascinating piece of the universe's history, it's a cornerstone of modern cosmology. Without it, the universe as we know it might not exist. Here's why. During inflation, the fabric of space-time stretched so rapidly that tiny quantum fluctuations, those random, microscopic ripples in energy, were magnified into the large-scale structures we see today. Galaxies, galaxy clusters, and even the cosmic web that connects them all trace their origins back to these early fluctuations. It's like blowing up a balloon with tiny dots on its surface. The dots grow farther apart, but their pattern remains, forever etched into the fabric of the universe. But cosmic inflation doesn't just explain the structure of the cosmos, it also hints at something even more profound. Some scientists believe that inflation didn't happen just once. Instead, it might be an ongoing process creating pocket universes within a much larger multiverse. Picture a vast cosmic ocean where bubbles of space-time form, expand, and drift apart. Each bubble could be its own universe with its own laws of physics and its own unique history. If this is true, then the edge of our observable universe might not be the end of everything. It could be the boundary of one bubble among countless others. This raises an intriguing question. Could the regions of space forever beyond our reach be remnants of inflation? As the universe expanded during that brief but explosive period, some areas of space may have been pushed so far away that their light will never reach us. These regions, sometimes called inflationary horizons, are like islands drifting in an infinite sea, forever out of sight, yet still part of the greater cosmic fabric. It's a humbling reminder that even the observable universe, vast as it is, might be just a small piece of a much larger puzzle. So, how do we know cosmic inflation actually happened? The evidence comes from the cosmic microwave background radiation, the afterglow of the Big Bang. This faint glow, which fills the entire sky, carries tiny temperature variations that match the predictions of inflation theory. These variations are like fingerprints, revealing the conditions of the early universe and confirming that it underwent a period of rapid expansion. It's as if the universe left us a message etched in the fabric of space-time, waiting to be decoded. But cosmic inflation isn't just about the past, it's also about the future. If inflation continues in other regions of the multiverse, it could mean that new universes are constantly being born, each with its own destiny. Some might collapse back in on themselves, while others could expand forever, teeming with stars, galaxies, and perhaps even life. The idea challenges us to rethink what it means to be the universe. Are we just one chapter in an infinite cosmic story, or is there something more to our place in the grand scheme of things? As we explore the mysteries of cosmic inflation, we're reminded that the universe is a place of endless wonder. The rapid expansion that shaped our cosmos billions of years ago continues to influence its evolution today, from the largest galaxies to the tiniest particles. And while the edge of the observable universe might be a boundary for us, it could also be a gateway, a glimpse into a reality far larger and more complex than we ever imagined. So as we peer into the depths of space and time, we're not just uncovering the secrets of the universe, we're discovering the story of existence itself. Black holes, those enigmatic cosmic phenomena where gravity becomes so intense that nothing, not even light, can escape, have long captured our imagination. But what if these celestial giants are more than just cosmic vacuum cleaners? What if they're portals to realms beyond our understanding, gateways to other dimensions, or even entirely different universes? It's a tantalizing idea that pushes the boundaries of science and challenges our perception of reality. At the heart of every black hole lies the event horizon, a boundary so profound that crossing it means there's no turning back. Think of it as the point of no return, where the gravitational pull becomes so overwhelming that escape is impossible. But here's where it gets fascinating. While the event horizon marks the limit of what we can observe, it doesn't necessarily mark the end of the story. Beyond this boundary, the laws of physics as we know them break down and the mysteries deepen. Some theories suggest that within a black hole, space and time could twist and fold in ways that connect distant regions of the universe, or even bridge to entirely separate realities. One of the most intriguing possibilities is that black holes could be wormholes, cosmic shortcuts through the fabric of space-time. Imagine a tunnel connecting two distant points in the universe, or even linking two entirely different universes. While this idea might sound like science fiction, it's rooted in the equations of general relativity. The catch, traveling through a wormhole would require navigating extreme gravitational forces and surviving environments so hostile that even atoms would be torn apart. Yet, the mere possibility opens the door to questions about the nature of space, time, and the universe itself. But what about the singularity at the center of a black hole? The point where matter is crushed into infinite density. Here, our understanding of physics reaches its limits. The singularity is a place where the rules of the universe as we know them cease to apply and new, unknown laws take over. Some scientists speculate that the singularity could be a gateway to another universe, or perhaps a place where the fabric of reality is rewritten. It's a concept that's as thrilling as it is unsettling, offering a glimpse into the strange and uncharted territories of the cosmos. Interestingly, black holes might also hold clues about the edge of the observable universe. If the multiverse theory is correct and our universe is just one of many, black holes could be the points where these universes intersect. In this scenario, the event horizon might not just be a boundary, it could be a threshold, a place where one reality ends and another begins. While we can't yet observe what lies beyond the event horizon, the study of black holes continues to push the limits of our knowledge, offering tantalizing hints about what might exist at the very edges of existence. So, are black holes the key to unlocking the secrets of the cosmos? The answer remains elusive, but the questions they raise are as profound as they are inspiring. From wormholes to singularities, these cosmic enigmas challenge us to rethink our understanding of space, time, and the nature of reality itself. And as we peer into the depths of a black hole, we're not just exploring the limits of our universe, we're exploring the limits of human curiosity and imagination. Zooming in on the fabric of the universe, we arrive at a scale so small it defies imagination: quantum foam. Picture space-time not as a smooth, unbroken surface, but as a seething, turbulent sea, bubbling with fluctuations so tiny they're almost impossible to detect. This is the realm where the rules of quantum mechanics reign, and where the very structure of reality becomes a chaotic dance of energy and possibility. At this level, space-time itself is thought to be frothy and unstable, a phenomenon scientists call quantum foam. But what does this mean for the universe as a whole? And could this chaotic, unpredictable foundation hold clues about the edge of the cosmos? The concept of quantum foam emerges from the strange and counterintuitive world of quantum mechanics. At scales smaller than a trillionth of a millimeter, particles and energy fluctuate wildly, popping in and out of existence in a blur of activity. These fluctuations aren't just random, they're the result of the universe's most fundamental forces interacting in ways that challenge our understanding of reality. In this microscopic realm, space-time isn't smooth and continuous like we see on larger scales. Instead, it's a turbulent, ever-changing foam where tiny bubbles of space-time constantly form and dissolve. It's as if the universe itself is built on a foundation of chaos. But how does this chaotic foundation affect the cosmos on a larger scale? Some scientists believe that quantum foam could hold the key to understanding the very nature of space-time. If space-time is frothy and unstable at its core, then the smooth, predictable fabric we experience in our everyday lives might be an illusion, a kind of cosmic averaging out of countless tiny fluctuations. This idea challenges the way we think about the universe, suggesting that what we perceive as a stable, orderly cosmos is actually built on a foundation of randomness and uncertainty. Now, let's take this a step further. If space-time is inherently chaotic at the smallest scales, what happens at the edge of the observable universe? Could the boundary of the cosmos be a place where space-time breaks down entirely, dissolving into a sea of quantum foam? It's a mind-bending possibility, one that suggests the edge of the universe might not be a clean, well-defined line, but a region of extreme instability and unpredictability. In this scenario, the laws of physics as we know them could cease to apply, leaving us with a universe that's far stranger and more complex than we ever imagined. This idea also raises questions about the nature of reality itself. If space-time is frothy and unstable at its core, then our perception of a smooth, continuous universe might be just that, a perception. The true nature of reality could be far more chaotic and unpredictable, with the quantum foam acting as a kind of cosmic undercurrent that shapes the structure of the cosmos. It's a humbling thought, reminding us that even the most fundamental aspects of the universe are still shrouded in mystery. So, how do we study something as elusive as quantum foam? The challenge lies in its scale. these fluctuations are so small and short-lived that observing them directly is nearly impossible with current technology. However, scientists are exploring indirect methods, such as studying the behavior of particles in extreme environments or searching for subtle effects in the cosmic microwave background radiation. These efforts could one day provide clues about the true nature of spacetime and its role in shaping the universe. The implications of quantum foam stretch far beyond the microscopic. If spacetime is inherently chaotic, then the very fabric of the cosmos could be far more dynamic and unpredictable than we realize. This idea not only deepens our understanding of the universe, but also challenges us to rethink our place within it. The edge of the cosmos, once thought to be a distant, unreachable boundary, might instead be a region of profound transformation, a place where the rules of reality shift and the universe reveals its true, chaotic nature. As we explore the mysteries of quantum foam, we're reminded that the universe is a place of endless wonder and complexity. From the smallest scales to the farthest reaches of space, the cosmos continues to surprise us, offering glimpses of a reality that's far stranger and more beautiful than we ever imagined. And as we peer into the frothy depths of space-time, we're not just uncovering the secrets of the universe, we're discovering the story of existence itself. As we delve deeper into the mysteries of the cosmos, one of the most ambitious and elegant ideas emerges: string theory. At its core, this theory seeks to unify the two great pillars of modern physics: quantum mechanics, which governs the behavior of the very small, and general relativity, which describes the vastness of space and time. But how does it aim to bridge this divide? By proposing that the fundamental building blocks of the universe aren't particles, as we've long thought, but tiny, vibrating strings. These strings, unimaginably small and endlessly dynamic, could hold the key to understanding everything from the tiniest particles to the very edge of the universe. Imagine plucking a guitar string. Depending on how it vibrates, it produces different notes. String theory suggests something similar on a cosmic scale. These tiny strings vibrate in unique patterns, each one corresponding to a different particle or force. An electron, a photon, even gravity itself could all arise from the same underlying strings, just vibrating in different ways. It's a breathtakingly simple idea, yet one that could explain the complexity of the universe in a way no other theory has managed. But here's the twist: for string theory to work, the universe needs more dimensions than the 3 we're familiar with. In fact, it requires at least 10, possibly more. These extra dimensions, hidden from our everyday experience, could be curled up so tightly that we can't detect them, yet they might hold the secrets to the cosmos. Now let's zoom out to the edge of the universe. If string theory is correct, what does that mean for the boundaries of space and time? Could the edge of the cosmos be a place where these strings unravel or interact in ways we can't yet imagine? One intriguing possibility is that the edge isn't a hard boundary at all, but a region where the fabric of spacetime becomes so warped that the strings themselves stretch and twist in extraordinary ways. It's as if the universe's edge is less like a wall and more like a cosmic loom, weaving the threads of reality into something entirely new. String theory also offers a fascinating perspective on the multiverse. If these extra dimensions exist, they could house other universes, each with its own unique set of physical laws. Our universe might be just one sheet in a vast cosmic stack, separated by membranes of space-time. The edge of our observable universe, then, could be the point where our sheet meets another, creating a boundary that's not an end but a transition. It's a vision that transforms the edge from a limit into a gateway, a place where the rules of reality might shift in unexpected ways. But how do we test such a bold idea? One of the challenges of string theory is that its predictions often occur at energy scales far beyond what we can currently observe. Yet, scientists are exploring indirect methods, such as searching for tiny ripples in space-time or anomalies in particle collisions that could hint at the presence of strings. Advances in technology, like more powerful particle accelerators or deeper observations of the cosmic microwave background, might one day provide the evidence we need to confirm or refute this elegant theory. What makes string theory so compelling isn't just its potential to unify physics, but the way it reshapes our understanding of reality. It challenges us to think beyond the familiar, to imagine a universe where the fundamental nature of existence is more intricate and interconnected than we ever dreamed. From the tiniest strings to the farthest reaches of the cosmos, this theory invites us to explore a reality where the boundaries of space, time, and even dimensions blur into something profoundly beautiful. So, as we stand at the edge of our understanding, string theory offers a tantalizing glimpse into the hidden structure of the cosmos. It reminds us that the universe is not just a collection of stars and galaxies, but a symphony of vibrating strings, each one playing its part in the grand cosmic dance. And as we continue to unravel its mysteries, we're not just exploring the edge of the universe, we're discovering the music of existence itself. What if everything we see, touch, and experience is nothing more than an illusion, a cosmic mirage? This is the radical idea at the heart of the holographic principle, a theory that suggests the universe might not be the three-dimensional reality we perceive, but instead a two-dimensional projection of information encoded on its outer boundary. It's a concept that sounds more like science fiction than science, yet it's rooted in some of the most profound discoveries in physics. So, how could the entire universe be a hologram? And what does this mean for the edge of the cosmos? The holographic principle emerged from the study of black holes, those enigmatic objects where gravity becomes so intense that even light can't escape. In the 1970s, physicist Jacob Bekenstein discovered that the surface area of a black hole's event horizon, its point of no return, holds a surprising amount of information. Specifically, the amount of information is proportional to the area of the horizon, not the volume of the black hole itself. This discovery led to a startling realization: the information about everything that falls into a black hole isn't lost. Instead, it's encoded on the event horizon like a cosmic hard drive. This idea laid the groundwork for the holographic principle, which extends this concept to the entire universe. Here's where it gets even more mind-bending. If the universe is like a hologram, then all the information needed to describe it, every star, every galaxy, even every atom, could be encoded on a two-dimensional surface at its boundary. Think of it like a movie projected onto a screen. The images appear three-dimensional, but they're actually flat, created by light and shadow. In the same way, the holographic principle suggests that our three-dimensional reality might be a projection of information stored on the universe's outer edge. It's a concept that turns our understanding of space and time on its head. But how could we possibly test such an idea? One of the key pieces of evidence comes from the study of entropy, the measure of disorder in a system. Just as the information in a black hole is encoded on its surface, the holographic principle predicts that the entropy of the universe should also be proportional to its surface area, not its volume. Remarkably, calculations based on the cosmic microwave background radiation, the afterglow of the Big Bang, align with this prediction. It's as if the universe is whispering to us, hinting at its true holographic nature. The implications of the holographic principle are staggering. If the universe is a projection, then the edge of the cosmos isn't just a boundary, it's a canvas, a place where the information that defines reality is stored. This idea blurs the line between science and philosophy, raising profound questions about the nature of existence. Is reality an illusion? Are we just characters in a cosmic story, playing out a script written on the edge of the universe? These questions might not have clear answers, but they challenge us to rethink everything we thought we knew about the cosmos. What's even more intriguing is how this principle connects to the multiverse and the nature of space-time. If the universe is a hologram, then the fabric of reality might be far more flexible and interconnected than we realize. The boundaries between universes, dimensions, and even time itself could be illusions, created by the way information is encoded and projected. It's a vision of the cosmos that's as beautiful as it is bewildering, offering a glimpse into the hidden structure of existence. As we explore the holographic principle, we're reminded that the universe is far stranger and more complex than we ever imagined. The edge of the cosmos, once thought to be a distant, unreachable frontier, might instead be the key to understanding the very fabric of reality. And while the idea of a holographic universe might seem abstract, it invites us to see the cosmos in a new light, not as a collection of objects, but as a tapestry of information woven together in ways we're only beginning to understand. So, as we peer into the depths of space and time, we're not just exploring the edge of the universe, we're uncovering the story of existence itself. Imagine standing at the edge of the cosmos, where the fabric of space and time stretches and twists in ways that defy our everyday experience. Here, time itself doesn't flow as it does on Earth. It bends, slows, and even speeds up, depending on where you are and how fast you're moving. This phenomenon, known as time dilation, is one of the most mind-bending consequences of Einstein's theory of relativity. And as we venture closer to the edge of the universe, its effects become even more extreme, revealing a cosmos where time is anything but constant. To understand time dilation, let's start with gravity. According to Einstein's general theory of relativity, massive objects like stars and galaxies warp the fabric of spacetime around them. The stronger the gravitational pull, the more spacetime curves and the slower time moves. Think of it like a heavy ball placed on a trampoline. The deeper the dent, the more time slows down for anyone near that ball. Near the edge of the cosmos, where gravity from distant galaxies and dark matter dominates, time could flow at a completely different rate compared to what we experience here on Earth. But gravity isn't the only factor that warps time. Velocity plays a role too. According to Einstein's special theory of relativity, the faster you move through space, the slower time passes for you relative to someone standing still. This effect, known as velocity-based time dilation, becomes more pronounced as you approach the speed of light. At the edge of the universe, where galaxies are racing away from us at incredible speeds due to the expansion of space, time could be stretched and distorted in ways that challenge our understanding of reality. So, what does this mean for the edge of the cosmos? If time dilation is already noticeable near massive objects or at high speeds here in our corner of the universe, imagine how extreme it could be in regions where gravity is unimaginably strong or where galaxies are moving at near light speeds. Time might flow so slowly in some areas that billions of years could pass in what feels like moments to an outside observer. In other regions, time could speed up, creating bizarre scenarios where the past, present, and future blur together. This raises a fascinating question. Could the edge of the universe be a place where time behaves in ways we can't even comprehend? Some theories suggest that near the boundaries of the observable cosmos, space-time could become so warped that time itself might lose its meaning. It's a concept that challenges our most basic assumptions about reality, suggesting that the universe's edge isn't just a physical boundary, it's a frontier where the rules of time and space break down. But how do we know time dilation is real? One of the most famous examples comes from the Global Positioning System, or GPS. The satellites that power GPS orbit Earth at high speeds and experience weaker gravity than we do on the surface. As a result, their onboard clocks run slightly faster than clocks on the ground. If engineers didn't account for this time dilation, GPS calculations would be off by miles. It's a practical demonstration of how time can warp, even in our own backyard. Now, let's take this a step further. If time dilation is already affecting our technology here on Earth, what does it mean for the far reaches of the cosmos? Could civilizations near the edge of the universe experience time in a completely different way? Imagine a world where days stretch into centuries or where entire lifetimes pass in the blink of an eye. It's a thought that not only stretches our imagination, but also reminds us of how much we still have to learn about the universe. As we explore the mysteries of time dilation, we're reminded that the cosmos is a place of endless wonder and complexity. From the smallest particles to the farthest reaches of space, the universe continues to surprise us, offering glimpses of a reality that's far stranger and more beautiful than we ever imagined. And as we peer into the depths of time and space, we're not just uncovering the secrets of the universe, we're discovering the story of existence itself. As we venture deeper into the mysteries of the cosmos, we encounter one of its most elusive inhabitants, dark matter. This invisible substance makes up roughly 27% of the universe, yet it refuses to reveal itself directly. We can't see it, touch it, or detect it with traditional instruments, yet its presence is undeniable. Dark matter is the cosmic scaffolding that holds galaxies together, shapes the large-scale structure of the universe, and influences its very expansion. But what exactly is it, and could the edge of the cosmos be a place where dark matter reigns supreme? Dark matter's story begins with a puzzle. In the 1930s, astronomer Fritz Zwicky noticed something strange about the Coma Cluster, a massive group of galaxies. The galaxies were moving so fast that, according to the laws of gravity, they should have flown apart, but they didn't. Something unseen was holding them together, providing the extra gravitational pull needed to keep the cluster intact. Zwicky called this mysterious substance dark matter. And though it was a radical idea at the time, it's now a cornerstone of modern cosmology. Fast forward to today, and we know dark matter isn't just a cosmic oddity, it's everywhere. It forms vast, invisible halos around galaxies, acting like an unseen glue that binds stars and gas together. Without it, galaxies would spin apart, and the universe as we know it wouldn't exist. But here's the catch: despite its overwhelming influence, we still don't know what dark matter actually is. It doesn't interact with light, making it invisible to telescopes. It doesn't collide with ordinary matter, meaning it passes through us unnoticed. It's like a ghost haunting the cosmos, shaping its destiny while remaining forever hidden. So, how do we know dark matter exists if we can't see it? The answer lies in its gravitational effects. When light from distant galaxies passes through a region of dark matter, it bends, creating a phenomenon called gravitational lensing. This bending of light allows astronomers to map the distribution of dark matter, revealing its presence in the vast voids between galaxies and the dense cores of galaxy clusters. It's as if the universe is leaving us clues written in the language of gravity, waiting to be deciphered. Now, let's zoom out to the edge of the cosmos. Could dark matter play a role in shaping this mysterious boundary? Some scientists believe that dark matter might dominate the farthest reaches of the universe, acting as a kind of cosmic anchor that influences how space expands. In this scenario, the edge of the observable universe might not be defined by the limits of light or the expansion of space. It could be shaped by the gravitational pull of dark matter itself. It's a tantalizing idea, suggesting that the true nature of the cosmos might be hidden in the invisible web that stretches across its farthest reaches. But the story of dark matter doesn't end there. Its influence extends beyond gravity and into the very fabric of the universe's evolution. In the early cosmos, dark matter acted as a seed for the formation of galaxies and galaxy clusters. Tiny fluctuations in its density grew over time, pulling ordinary matter into its gravitational embrace and giving birth to the structures we see today. Without dark matter, the universe would be a far emptier, darker place, a cosmic desert devoid of stars, planets, and life. Yet, despite its critical role, dark matter remains one of the greatest unsolved mysteries in science. What is it made of? Is it a particle or something entirely different? And could it hold the key to understanding the edge of the universe? These questions drive some of the most ambitious experiments in modern physics, from enormous detectors buried deep underground to powerful telescopes scanning the skies for clues. Every discovery brings us closer to unraveling the secrets of this invisible force, and with it, the true nature of the cosmos. As we explore the enigma of dark matter, we're reminded that the universe is full of surprises. What we can't see is often just as important as what we can, and the invisible scaffolding of dark matter might be the key to understanding the grand design of existence. So, as we peer into the depths of space, let's not forget the unseen forces that shape our reality, because sometimes the most profound mysteries are the ones hidden in plain sight. The universe is unimaginably vast, with billions of galaxies, each containing billions of stars and planets. With so many places for life to potentially thrive, it's natural to wonder, where is everyone? This is the heart of the Fermi Paradox, a question that has puzzled scientists and thinkers for decades. If the cosmos is so expansive and filled with possibilities, why haven't we found any evidence of extraterrestrial civilizations? Could the edge of the universe hold the answers we've been searching for? Let's explore some of the most intriguing explanations for this cosmic silence. One of the simplest explanations is that life might be incredibly rare. Even in a universe teeming with planets, the conditions needed for life to emerge and evolve into intelligent civilizations could be vanishingly scarce. Think of it like a needle in a cosmic haystack. Earth might be one of the lucky few planets where the right combination of chemistry, temperature, and stability allowed life to flourish. If this is the case, then the silence we hear might not be a mystery at all. It could simply reflect the rarity of life itself. But what if life isn't rare? What if intelligent civilizations are out there, but they're just too far away for us to detect? The observable universe is enormous, but it's still limited by the speed of light. Signals from distant civilizations might not have reached us yet, or they might be too faint to detect with our current technology. It's like trying to hear a whisper across an ocean. No matter how loud the whisper might be, the distance makes it almost impossible to pick up. Could the edge of the cosmos be hiding civilizations whose light and signals haven't had enough time to reach us? Another possibility is that advanced civilizations might intentionally avoid contact. Imagine a universe filled with intelligent beings, each one cautious about revealing their presence. Perhaps they've learned that contact with less advanced species can lead to chaos or destruction, or maybe they've developed technologies that make them invisible to our detection methods. In this scenario, the silence isn't a sign of absence, it's a deliberate choice, a cosmic game of hide and seek where the rules are written by civilizations far beyond our understanding. Then there's the idea that advanced civilizations might not last long enough to be detected. The rise and fall of species could be a universal pattern, with intelligent life emerging, flourishing, and then self-destructing before they have a chance to explore the stars. Nuclear war, environmental collapse, or even the misuse of advanced technologies could all be factors that limit the lifespan of civilizations. If this is true, then the silence might be a tragic reminder of the fragility of intelligence itself. But let's take this a step further. What if the answers to the Fermi Paradox lie beyond the edge of our observable universe? If the cosmos is far larger than what we can see, or even infinite, then the civilizations we're searching for might exist in regions of space that are forever out of reach. These regions could be hidden by the expansion of the universe, their light and signals stretched beyond detection by the relentless pull of dark energy. In this scenario, the edge of the cosmos isn't just a boundary, it's a veil concealing answers that might forever remain beyond our grasp. The Fermi Paradox isn't just a question about extraterrestrial life, it's a mirror that reflects our own place in the universe. It challenges us to think about the nature of life, the fate of civilizations, and the limits of our knowledge. And while the answers remain elusive, the search itself is a testament to our curiosity and determination to understand the cosmos. Whether the edge of the universe hides civilizations, rare life, or simply the echoes of long-lost species, one thing is certain. The mystery of the Fermi Paradox reminds us that the universe is full of questions waiting to be answered, and that the journey to find them is just as important as the destination. Imagine the universe as a vast, intricate tapestry woven together by the threads of space and time. But what if, in the earliest moments of creation, tiny imperfections, ripples, or tears were left behind in this cosmic fabric? These imperfections, known as cosmic strings, are one of the most fascinating and elusive concepts in modern physics. Hypothetical yet profound, they're thought to be one-dimensional defects in spacetime, remnants of the universe's fiery birth. And while we've yet to detect them, their potential effects on the cosmos could be immense. Could these cosmic threads hold the key to understanding the very boundaries of existence? Let's unravel the mystery of cosmic strings and explore how they might shape the edge of the universe. Cosmic strings are believed to have formed during the universe's infancy, just moments after the Big Bang. As the cosmos expanded and cooled, phase transitions occurred, shifts in the fundamental forces that govern reality. Think of it like water freezing into ice. As it changes states, cracks and imperfections can form. In the same way, cosmic strings are thought to be cracks in spacetime itself, incredibly thin yet unimaginably dense. Some theories suggest they could stretch across the entire universe, forming vast, invisible networks that influence everything from the motion of galaxies to the distribution of matter. But what makes cosmic strings so intriguing isn't just their origin, it's their potential impact. These spacetime defects are thought to possess immense gravitational pull, capable of bending light and distorting the path of nearby objects. If a cosmic string were to pass through a galaxy, it could create a lensing effect, magnifying or distorting the light from distant stars. Astronomers have been searching for these telltale distortions, hoping to catch a glimpse of these cosmic threads in action. Yet so far, they've remained elusive, leaving their existence as one of the great unanswered questions in cosmology. Now, let's zoom out to the edge of the cosmos. Could cosmic strings play a role in defining the boundaries of the universe? Some scientists speculate that these spacetime defects might cluster near the farthest reaches of the observable universe, acting as markers or even gateways to what lies beyond. If the universe is a tapestry, cosmic strings could be the stitches that hold it together, or the threads that lead us to its edge. It's a tantalizing idea, suggesting that the boundary of the cosmos might not be a smooth, unbroken surface, but a region crisscrossed by these ancient ripples in spacetime. What's even more fascinating is how cosmic strings might connect to other cosmic phenomena. For instance, they could influence the formation of galaxies, acting as gravitational seeds that pull matter together to form the large-scale structures we see today. They might even play a role in the universe's expansion, subtly shaping the way space stretches and evolves over time. In this way, cosmic strings aren't just relics of the early universe. They could be active participants in its ongoing story, weaving the fabric of reality in ways we're only beginning to understand. But how do we search for something so elusive? scientists are exploring a variety of methods, from studying the cosmic microwave background for subtle imprints left by cosmic strings to monitoring the motion of distant galaxies for signs of their gravitational influence. Advanced telescopes and detectors, like those designed to observe gravitational waves, could one day provide the evidence we need to confirm their existence. It's a challenging quest, but one that could revolutionize our understanding of the cosmos. The idea of cosmic strings invites us to think of the universe not as a static, unchanging expanse, but as a dynamic, ever-evolving structure shaped by its earliest moments. These hypothetical defects remind us that the cosmos is full of surprises, with mysteries lurking in every corner, even in the fabric of space-time itself. And as we explore the possibilities, we're not just uncovering the secrets of the universe, we're discovering the story of existence, one thread at a time. Deep within the cosmic web, there's a force so powerful that it's pulling entire galaxies, including our own Milky Way, toward it at incredible speeds. This mysterious phenomenon, known as the Great Attractor, has puzzled astronomers for decades. Hidden behind the dense plane of our galaxy, this gravitational anomaly exerts an irresistible pull, drawing thousands of galaxies into its grasp. But what exactly is the Great Attractor, and could this enigmatic force hold clues to what lies at the edge of the cosmos? Let's dive into this cosmic mystery and explore how it might reshape our understanding of the universe. The story of the Great Attractor begins with a peculiar observation. In the 1970s, astronomers noticed that galaxies in our local universe weren't just moving randomly. They were all streaming toward a specific point in space. This motion couldn't be explained by the expansion of the universe alone. Something massive, something hidden, was tugging on these galaxies, pulling them in like a cosmic magnet. But what could it be? The answer lies in the realm of gravity, the force that shapes the universe on the grandest scales. To understand the Great Attractor, we need to think about how gravity works on a cosmic level. Massive objects like galaxies and galaxy clusters create gravitational fields that influence everything around them. The larger the object, the stronger its pull. The Great Attractor appears to be an immense concentration of mass so massive that its gravitational influence extends across hundreds of millions of light years. Yet, despite its overwhelming presence, it remains shrouded in mystery. Why? Because it lies in a region of space obscured by the dust and stars of our own Milky Way, making it incredibly difficult to observe directly. So, how do we study something we can't see? Astronomers use indirect methods such as measuring the motion of galaxies and mapping the cosmic microwave background radiation. These tools allow them to infer the presence of the Great Attractor and estimate its mass. What they've found is astonishing. The Great Attractor isn't just a single object, but a vast region of space dominated by a supercluster of galaxies known as the Norma cluster. This cluster, along with other massive structures, creates a gravitational well so deep that it pulls galaxies from across the universe toward it. But here's where it gets even more intriguing. The Great Attractor might not be the ultimate source of this cosmic tug-of-war. Beyond it lies an even larger structure, the Shapley supercluster, the most massive concentration of galaxies in the observable universe. Some scientists believe that the Shapley supercluster is the true driver behind the motion of galaxies, with the Great Attractor acting as a kind of waypoint on the journey. This raises a fascinating question. Could these massive structures be part of an even larger cosmic pattern, one that stretches to the edge of the universe? The implications of the Great Attractor go beyond just gravity. It offers a glimpse into the large-scale structure of the cosmos, revealing how galaxies and clusters are interconnected in a vast, intricate web. This web, shaped by dark matter and dark energy, is the scaffolding of the universe, and the Great Attractor is one of its most prominent knots. understanding its role could help us unravel the mysteries of cosmic evolution and the forces that drive it. But what does this mean for the edge of the universe? Could the great attractor and structures like it be signposts pointing us toward the boundaries of the cosmos? Some theories suggest that these massive gravitational anomalies might be connected to the universe's expansion, influencing how space stretches and evolves over time. If that's the case, then studying the great attractor could bring us closer to understanding the ultimate fate of the universe itself. As we explore the mysteries of the great attractor, we're reminded that the universe is full of surprises. What we can't see is often just as important as what we can, and the hidden forces shaping our reality might hold the key to understanding the grand design of existence. So, as we peer into the depths of space, let's not forget the unseen forces that shape our reality, because sometimes the most profound mysteries are the ones hidden in plain sight. Imagine a planet orbiting a star so distant that its light has traveled billions of years to reach us, a world so far removed from our solar system that it exists on the very fringes of the observable universe. This isn't science fiction, it's the thrilling reality of exoplanet exploration. Over the past few decades, the discovery of planets beyond our solar system has transformed our understanding of the cosmos, revealing a staggering diversity of worlds. From scorching gas giants to rocky planets nestled in the habitable zones of their stars, exoplanets have opened our eyes to the infinite possibilities of the universe. But what if some of these distant worlds lie near the edge of the cosmos, in regions of space we can't yet observe? Could they hold secrets about the nature of the universe itself? The search for exoplanets began in earnest in the 1990s, when astronomers first detected a planet orbiting a sun-like star. Since then, thousands of exoplanets have been discovered, each one adding a new piece to the puzzle of our cosmic neighborhood. These worlds come in all shapes and sizes. Some are shrouded in thick atmospheres, while others are barren and rocky. Some orbit so close to their stars that their surfaces are molten, while others drift in the icy darkness of space. This incredible variety suggests that the universe is far more dynamic and diverse than we ever imagined. But how do we find these distant worlds? One of the most effective methods is the transit technique, which involves measuring the slight dimming of a star's light as a planet passes in front of it. Another approach is the radial velocity method, which detects the subtle wobble of a star caused by the gravitational pull of an orbiting planet. These techniques, along with advancements in telescope technology, have allowed us to uncover exoplanets in ever more distant regions of space. Yet, the farther we look, the more questions arise. Could there be planets orbiting stars so distant that their light hasn't reached us yet? And if so, what might those worlds be like? The idea of exoplanets existing near the edge of the observable universe is both tantalizing and challenging. As we peer deeper into space, we're also looking further back in time, to a period when the universe was younger and less developed. Stars in these distant regions might be very different from the ones we see today, and the planets orbiting them could offer clues about the early conditions of the cosmos. For example, some of these worlds might be remnants of the first generation of planets, formed when the universe was still in its infancy. Studying them could provide a window into the processes that shaped the early universe and the origins of life itself. Yet, the search for these distant exoplanets is fraught with challenges. The light from their stars is incredibly faint, and the vast distances make it difficult to detect the subtle signs of orbiting planets. Additionally, the expansion of the universe means that some of these worlds might forever remain beyond our reach, their light stretched and redshifted to the point of invisibility. But even if we can't observe them directly, their existence raises profound questions about the nature of the cosmos. Are these distant worlds part of a larger cosmic pattern, or are they unique anomalies shaped by the specific conditions of their regions? The discovery of exoplanets has not only expanded our understanding of the universe but also deepened its mystery. Each new world we find challenges our assumptions and pushes the boundaries of what we thought was possible. From the scorching heat of lava planets to the icy calm of worlds orbiting red dwarfs, the diversity of exoplanets reminds us that the cosmos is a place of endless wonder and surprise. And as we continue to explore, we're not just searching for new planets, we're uncovering the story of the universe itself, one world at a time. So, what might we find as we push the boundaries of exoplanet exploration? Could the edge of the cosmos hold worlds that defy our expectations, shaped by forces we've yet to understand? The answers remain hidden, waiting for the next generation of telescopes and technologies to reveal them. But one thing is certain, the search for exoplanets is a journey that will continue to inspire and challenge us, offering glimpses of a universe far more complex and beautiful than we ever imagined. Picture the universe not as a random scattering of stars and galaxies, but as an intricate, interconnected web, a cosmic tapestry woven from threads of galaxies, gas, and dark matter. This awe-inspiring structure, known as the cosmic web, is the hidden framework that holds the universe together. It's a network so vast that it stretches across billions of light years, shaping everything from the largest galaxy clusters to the tiniest pockets of space. But what exactly is the cosmic web, and how does it influence the very boundaries of the universe? Let's untangle this cosmic mystery and explore how this hidden structure might hold the key to understanding the edge of existence. At its core, the cosmic web is the result of gravity's relentless pull. In the early universe, tiny fluctuations in density ripples left over from the Big Bang created regions where matter began to clump together. Over billions of years, these clumps grew, forming the filaments and nodes that make up the web. Imagine it like a spider's silk stretching across the cosmos with galaxies strung along its strands like pearls. These filaments connect massive galaxy clusters, while the voids between them are vast, empty regions where matter is sparse. It's a structure so immense that it's almost impossible to visualize, yet it's the backbone of the universe itself. But the cosmic web isn't just a static framework. It's a dynamic, evolving network. Dark matter, the invisible glue that makes up most of the universe's mass, plays a crucial role in shaping and sustaining it. As galaxies and gas flow along the filaments, they're drawn toward the densest nodes where galaxy clusters reside. This constant motion, driven by gravity, creates a cosmic dance that has been playing out since the universe's birth. And just as the web connects galaxies and clusters, it also connects us to the larger story of the cosmos, offering clues about how the universe formed and how it continues to evolve. Now, let's zoom out to the edge of the observable universe. Could the cosmic web hold the key to understanding this mysterious boundary? Some scientists believe that the web's structure might extend far beyond what we can see, its filaments stretching into regions of space that are forever out of reach. If that's the case, then the edge of the universe might not be a hard, impenetrable barrier, but a place where the web begins to unravel, its filaments thinning out and dissolving into the void. It's a concept that challenges our understanding of the cosmos, suggesting that the universe's boundary might be more like a gradual fading than a sharp edge. What's even more fascinating is how the cosmic web connects to the universe's expansion. As dark energy pushes galaxies apart, the filaments of the web stretch and thin, altering the distribution of matter over time. This means that the web isn't just a relic of the past, it's a living, breathing structure that continues to shape the cosmos. Near the edge of the universe, where expansion is most extreme, the web might behave in ways we can't yet predict, offering a glimpse into the forces that govern the universe's ultimate fate. But how do we study something so vast and complex? Astronomers use powerful telescopes and computer simulations to map the cosmic web. tracing the paths of galaxies and gas as they flow along its filaments. By studying these patterns, they can uncover the web's hidden secrets, from the distribution of dark matter to the effects of dark energy. It's a monumental task, but one that brings us closer to understanding the universe's grand design. The cosmic web is more than just a scientific concept. It's a reminder of the universe's interconnectedness. Every galaxy, every star, and every atom is part of this vast network, bound together by the forces of gravity and the mysteries of dark matter. As we explore its structure, we're not just mapping the cosmos, we're uncovering the story of existence itself. And as we peer into the farthest reaches of the universe, we're reminded that the answers to our deepest questions might be woven into the very fabric of the cosmic web. Light has been humanity's greatest guide in unraveling the mysteries of the cosmos. From the twinkle of distant stars to the faint glow of the cosmic microwave background, light carries the stories of galaxies, planets, and even the birth of the universe itself. But as powerful as it is, light has its limits that shape not only what we can see but also what we can know. The speed of light, while astonishingly fast, is finite. This means that when we peer into the depths of space, we're also looking back in time. Every beam of light that reaches us is a snapshot of the universe's past, a glimpse into a distant era when the cosmos was younger and vastly different from what it is today. This interplay between light and time creates a fascinating paradox. The farther we look, the older the light we see. The light from the sun takes about 8 minutes to reach Earth, meaning we see it as it was 8 minutes ago. The light from the nearest star system, Proxima Centauri, takes over 4 years to reach us, and when we gaze at the Andromeda galaxy, we're seeing light that left its stars more than 2.5 million years ago. But what happens when we push our observations to the very edge of the observable universe? The light we detect from these distant regions has traveled for billions of years, offering us a window into the universe's infancy. Yet, because the universe is expanding, this light is also stretched and dimmed, a phenomenon known as redshift. This stretching of light makes it increasingly difficult to observe the farthest reaches of the cosmos, effectively creating a boundary to what we can see. The expansion of the universe adds another layer of complexity. As space itself stretches, galaxies are carried away from each other at speeds that can exceed the speed of light. This doesn't violate the laws of physics because it's space that's expanding, not the objects within it moving through space. But it does mean that light from galaxies beyond a certain distance will never reach us. These regions of the universe are forever beyond our observational horizon, hidden by the relentless pull of cosmic expansion. It's as if the universe is constantly redrawing its boundaries, pushing the edge of what we can observe further and further away. So, could the edge of the cosmos be a place where light simply can't reach us? The answer is both yes and no. On one hand, the observable universe has a boundary defined by the distance light has had time to travel since the Big Bang about 13.8 billion years. Beyond that, light hasn't had enough time to reach us, and those regions remain shrouded in mystery. On the other hand, the universe itself may extend far beyond what we can observe, with galaxies and structures that we'll never see because their light will never reach us. This raises a profound question. Is the edge of the cosmos a physical boundary, or is it simply the limit of our perception? The role of light in mapping the cosmos also highlights the delicate balance between discovery and limitation. While light allows us to explore the universe, it also defines the edges of our knowledge. Every observation we make is constrained by the finite speed of light and the ever-expanding fabric of space. Yet, these limitations aren't just barriers, they're also opportunities. By studying the light we can see, we can infer the presence of what we can't. The faint echoes of the Big Bang, the subtle distortions of gravitational lensing, and the shifting wavelengths of redshift all offer clues about the universe's hidden depths. As we continue to push the boundaries of observation, new technologies are helping us see further and clearer than ever before. Telescopes like the James Webb Space Telescope are designed to detect the faintest, most distant light, offering glimpses into the earliest moments of cosmic history. These advancements remind us that while light may define the limits of our current understanding, it also holds the key to unlocking the universe's deepest secrets. The edge of the cosmos isn't just a boundary, it's a frontier, a place where the known meets the unknown, and where every discovery brings us closer to understanding the true nature of existence. Imagine the universe as a vast, tranquil pond. Now picture dropping a massive rock into its center. The impact creates ripples that spread outward, distorting the water's surface in all directions. In a similar way, the cosmos has its own ripples, gravitational waves produced not by rocks, but by some of the most cataclysmic events imaginable. These waves, first predicted by Einstein over a century ago, are disturbances in the very fabric of spacetime itself, caused by the movement of massive objects like colliding black holes or merging neutron stars. But gravitational waves are more than just cosmic curiosities. They're a groundbreaking tool for studying the universe, offering a new way to listen to the cosmos and explore its deepest mysteries, including what might lie at its very edge. Gravitational waves were first detected in 2015 by the Laser Interferometer Gravitational Wave Observatory, or LIGO, marking a monumental milestone in science. The waves detected came from the collision of two black holes over 1.3 billion light-years away, an event so powerful that it sent ripples through space-time, which traveled across the universe to reach us. Unlike light, which can be blocked or absorbed by dust and gas, gravitational waves pass through everything, carrying information about their origins untouched. This makes them an extraordinary window into the universe, allowing us to observe events that would otherwise remain hidden. But how do these ripples in space-time help us explore the edge of the cosmos? One of the most exciting possibilities is that gravitational waves could reveal phenomena that lie beyond the reach of traditional telescopes. For example, the early universe was filled with chaotic, high-energy events that left behind gravitational waves as a kind of cosmic echo. By detecting these ancient ripples, we might gain insights into the universe's infancy, including the moments just after the Big Bang. This could help us understand not only how the universe began, but also how it has evolved over billions of years, potentially shedding light on the nature of its boundaries. Gravitational waves also offer a unique perspective on the large-scale structure of the universe. As these ripples travel through space, they interact with the cosmic web, the vast network of galaxies and dark matter that shapes the cosmos. By studying how gravitational waves are distorted as they pass through this web, scientists can map the distribution of matter in the universe, including regions that are otherwise invisible. This could provide clues about the forces driving the universe's expansion and how these forces might influence its ultimate fate. Perhaps the most tantalizing possibility is that gravitational waves could help us probe the edge of the observable universe itself. If space-time has a boundary, whether it's a physical edge or a transition to another realm, gravitational waves might be the key to detecting it. These waves could carry information about the nature of space-time at its most extreme limits, offering hints about what lies beyond. It's a concept that pushes the boundaries of our imagination, suggesting that the universe's edge might not be a fixed point but a dynamic, ever-shifting frontier. The detection of gravitational waves has already transformed our understanding of the cosmos, from revealing the existence of intermediate mass black holes to providing new insights into the behavior of neutron stars. But their potential goes far beyond what we've discovered so far. As technology advances, we're building more sensitive detectors, like the upcoming Laser Interferometer Space Antenna, or LISA, which will be able to observe gravitational waves from even more distant and ancient sources. These advancements could open up entirely new avenues of exploration, allowing us to listen to the universe in ways we've never imagined. Gravitational waves remind us that the universe is not just a place of light and matter, but a dynamic, ever-changing tapestry of spacetime itself. They offer a new way to explore the cosmos, one that complements traditional observations and expands our understanding of reality. As we continue to detect and study these ripples in spacetime, we're not just uncovering the secrets of the universe, we're redefining how we explore it. And who knows, the next gravitational wave we detect might carry a message from the very edge of existence, revealing a universe far stranger and more wondrous than we ever dreamed. Now, let's turn our attention to one of the most thought-provoking ideas in cosmology, the anthropic principle. This concept suggests that the universe's fundamental constants and laws seem perfectly fine-tuned to allow for the existence of life. From the strength of gravity to the precise balance of forces that hold atoms together, everything appears to be calibrated just right. If any of these values were even slightly different, stars wouldn't form, atoms wouldn't bond, and life as we know it couldn't exist. But why is the universe so hospitable, and what does this say about the nature of reality itself? At its core, the anthropic principle challenges us to consider why the universe is the way it is. One interpretation, known as the weak anthropic principle, argues that we observe these fine-tuned conditions simply because we exist. In other words, if the universe weren't suited for life, we wouldn't be here to notice. It's a bit like winning the lottery, unlikely but not impossible. This perspective doesn't require any grand explanation. It simply acknowledges that the universe's properties are what they are, and life has emerged within those parameters. But there's a stronger version of the anthropic principle, one that delves deeper into the mysteries of existence. The strong anthropic principle suggests that the universe's fine-tuning isn't just a coincidence, it's a necessity. Some theorists propose that this fine-tuning points to the existence of a multiverse where countless universes exist, each with its own set of physical laws. In this scenario, we happen to live in one of the rare universes where the conditions are just right for life. It's a mind-bending idea, but one that offers a potential explanation for why our universe seems so perfectly designed. Now, let's take this a step further. If the universe is fine-tuned for life, what does that mean for the edge of the cosmos? Could there be regions where these conditions no longer hold, where the delicate balance of forces breaks down and life becomes impossible? Some scientists speculate that at the farthest reaches of the universe, the laws of physics might shift in ways we can't yet comprehend. Perhaps the fine-tuning we observe here is a local phenomenon, limited to our observable universe, while the edge represents a boundary where the rules change. This raises a profound question. Does the anthropic principle apply only to our corner of the cosmos, or is it a universal truth? If the universe is infinite, as some theories suggest, there could be regions where life is impossible and others where it flourishes. The edge of the observable universe might not just be a physical boundary, it could be a transition point where the conditions that support life give way to something entirely different. It's a concept that challenges our understanding of existence and invites us to rethink our place in the grand scheme of things. The anthropic principle also forces us to confront the nature of life itself. If the universe is fine-tuned for life, does that mean life is a fundamental part of its design? Or is life a rare, fragile phenomenon, dependent on a precise set of conditions that might not exist elsewhere? These questions don't just belong to science, they touch on philosophy, theology, and the very meaning of existence. They remind us that the universe isn't just a collection of stars and galaxies. It's a stage where life, consciousness, and curiosity have emerged, allowing us to ask these questions in the first place. As we explore the implications of the anthropic principle, we're reminded that the universe is full of mysteries waiting to be uncovered. From the fine-tuning of physical constants to the possibility of life beyond our observable universe, this principle offers a lens through which we can examine the cosmos and our place within it. Whether the edge of the universe holds answers or simply more questions, the journey to understand it is a testament to our curiosity and our desire to make sense of the world around us. So, as we ponder the anthropic principle, let's remember, the universe isn't just a place to explore, it's a story to be discovered, one question at a time. As we journey through the mysteries of the cosmos, there's one tool that has proven indispensable in our quest for understanding: mathematics. Often called the language of the universe, mathematics is the framework that allows us to decode the secrets of space, time, and everything in between. From the motion of planets to the behavior of black holes, math provides the equations and models that describe how the universe works. But what happens when we push these models to their limits? Could the edge of the cosmos be a place where even the most elegant equations fail to explain what we find? Let's explore how mathematics shapes our understanding of the universe and what it might reveal about the boundaries of reality. At its heart, mathematics is a way of describing patterns that exist not just in our minds but in the fabric of the universe itself. Take gravity, for example. Isaac Newton's law of universal gravitation, expressed in a simple equation, allowed us to predict the motion of planets with remarkable accuracy. Centuries later, Einstein's theory of general relativity refined that understanding, using complex equations to describe how massive objects warp spacetime. These mathematical models don't just describe the universe, they allow us to predict its behavior, from the orbits of satellites to the bending of light around galaxies. Without math, our understanding of the cosmos would be little more than guesswork. But as powerful as mathematics is, it's not without its limits. When we venture into the extreme realms of the universe, near the singularity of a black hole, or at the very edge of the observable cosmos, our current models begin to falter. For instance, general relativity and quantum mechanics, two of the most successful theories in physics, are fundamentally at odds with each other. General relativity describes the universe on large scales, while quantum mechanics governs the behavior of particles on the smallest scales. Yet, when we try to combine these theories to describe the universe as a whole, the math breaks down. This suggests that there might be regions of the cosmos where our current understanding simply doesn't apply. So, what does this mean for the edge of the universe? Some scientists believe that at the farthest reaches of space, the rules of mathematics, and by extension, the laws of physics, might change. It's possible that the boundary of the observable universe isn't just a physical limit but a mathematical one, a place where the equations we rely on to describe reality no longer hold. This idea isn't just speculative, it's rooted in the quest for a unified theory of everything, a single set of equations that can describe the entire cosmos, from the smallest particles to the largest structures. While we haven't yet found such a theory, the search itself is pushing the boundaries of mathematics and challenging our understanding of the universe. One fascinating possibility is that the edge of the cosmos could be a place where new mathematical concepts emerge. Just as calculus was invented to describe motion and change, the mysteries of the universe's boundary might require entirely new branches of mathematics. For example, string theory, which proposes that the fundamental building blocks of the universe are tiny, vibrating strings, relies on advanced mathematical frameworks that go far beyond traditional physics. If the edge of the universe is governed by similar principles, it could open up entirely new ways of thinking about space, time, and reality itself. But even if our mathematical models break down at the edge of the universe, they still provide a powerful tool for exploring the unknown. By using math to test hypotheses and simulate scenarios, we can make educated guesses about what lies beyond our observational horizon. These predictions, while speculative, help guide our search for answers and inspire new questions. In this way, mathematics isn't just a language for describing the cosmos, it's a bridge to the unknown, a way of exploring the mysteries that lie just beyond our reach. The role of mathematics in understanding the cosmos is a testament to the power of human curiosity and ingenuity. It reminds us that the universe, while vast and complex, is not beyond comprehension. Through the language of mathematics, we've been able to unlock the secrets of stars, galaxies, and even the origins of the universe itself. And as we continue to push the boundaries of our knowledge, we're reminded that the journey to understand the cosmos is as much about discovery as it is about imagination. So, while the edge of the universe might remain shrouded in mystery, one thing is certain: mathematics will be our guide, helping us navigate the unknown and uncover the story of existence itself. Imagine a universe so vast that it contains billions of galaxies, each with billions of stars and planets. In such a cosmos, it seems almost unimaginable that we're the only intelligent beings. Yet, despite decades of searching, we've found no definitive evidence of extraterrestrial life. This is the heart of the search for extraterrestrial intelligence, or SETI, a scientific endeavor that seeks to answer one of humanity's most profound questions: are we alone? By scanning the skies for signals from distant civilizations, SETI not only explores the possibility of life beyond Earth, but also pushes the boundaries of what we know about the universe itself. The search for extraterrestrial intelligence is a monumental task fraught with challenges that stretch the limits of our technology and imagination. One of the biggest hurdles is distance. Even the closest stars are light years away, meaning any signals we detect would have traveled for years, decades, or even millennia to reach us. This creates a communication lag that makes real-time interaction with potential alien civilizations impossible. To make matters more complex, the universe is a noisy place. Natural phenomena like pulsars, quasars, and cosmic radiation produce signals that can mimic those of intelligent origin, making it difficult to distinguish between a genuine alien message and cosmic static. Then there's the question of what we're even looking for. Alien civilizations, if they exist, might communicate in ways we can't yet imagine. They could use technologies far beyond our understanding, transmitting signals on frequencies we haven't thought to explore. Or they might not use electromagnetic signals at all, relying instead on methods like gravitational waves or neutrinos to convey information. This uncertainty means SETI researchers must cast a wide net, scanning the skies across a broad range of frequencies and searching for patterns that stand out from the cosmic background noise. Despite these challenges, the search has yielded tantalizing possibilities. In 1977, the famous WOW signal was detected, a strong, narrowband radio signal that appeared to come from the direction of the constellation Sagittarius. Lasting just 72 seconds, it remains one of the most compelling candidates for an alien transmission, though it has never been detected again. More recently, fast radio bursts, brief, intense pulses of radio waves from deep space, have sparked speculation about their origins, though most are believed to have natural causes. These fleeting moments of excitement highlight both the promise and the frustration of SETI. The universe is full of mysteries, but definitive proof of extraterrestrial intelligence remains elusive. But what does SETI tell us about the edge of the cosmos? Could the farthest reaches of the universe be teeming with intelligent life, hidden by the vast distances and the limits of our technology? Some scientists speculate that advanced civilizations might exist in regions of space so distant that their signals haven't had time to reach us. Others suggest that the edge of the observable universe might be a place where unique conditions such as the presence of exotic forms of matter or energy could foster life in ways we can't yet comprehend. These ideas push the boundaries of our understanding, suggesting that the universe's edge might not just be a physical frontier, but a frontier of possibility. The search for extraterrestrial intelligence also forces us to confront profound questions about our place in the universe. If we're alone, what does that say about the rarity of life and the conditions needed to sustain it? If we're not alone, what might contact with another civilization reveal about the nature of intelligence, culture, and existence itself? These questions don't just belong to science, they touch on philosophy, ethics, and the very meaning of being human. SETI reminds us that the universe is not just a place to explore, it's a place to wonder, to dream, and to imagine what might lie beyond the boundaries of our knowledge. As we continue to scan the skies, the search for extraterrestrial intelligence remains a testament to human curiosity and ingenuity. It's a quest that unites scientists, dreamers, and thinkers across the globe, driven by the hope that somewhere out there, another civilization might be asking the same questions we are. And while the answers remain hidden, the journey itself is a reminder that the universe is full of surprises, waiting for us to uncover them, one signal, one discovery at a time. In the quest to understand the universe, we're no longer limited by human capacity alone. Enter artificial intelligence, a tool that's transforming how we explore the cosmos. From sifting through mountains of telescope data to uncovering patterns invisible to the human eye, AI is becoming an indispensable partner in our cosmic journey. But how exactly is this technology reshaping our understanding of the universe? And could it hold the key to unlocking the mysteries of the cosmos's farthest reaches? One of the most significant challenges in modern astronomy is the sheer volume of data we collect. Telescopes like the Hubble and the James Webb Space Telescope generate terabytes of information every day, capturing everything from distant galaxies to the faintest glimmers of light from the early universe. For scientists, this flood of data is both a blessing and a burden. It's rich with potential discoveries, but manually analyzing it is like searching for a needle in a cosmic haystack. That's where AI steps in. By using machine learning algorithms, researchers can train computers to sift through this data, identifying patterns and anomalies that might otherwise go unnoticed. For instance, AI has already been used to discover new exoplanets, classify galaxies, and even detect gravitational waves, all tasks that would take humans years to accomplish. But AI's role in cosmic exploration goes beyond data analysis. It's also helping us simulate and predict cosmic phenomena with unprecedented accuracy. Take black holes, for example. These enigmatic objects are impossible to observe directly, but by feeding AI models with data from simulations and observations, scientists can better understand their behavior and structure. Similarly, AI is being used to model the large-scale structure of the universe, from the cosmic web to the distribution of dark matter. These simulations not only enhance our understanding of the cosmos, but also provide testable predictions that guide future observations. Perhaps the most intriguing question is whether AI could help us uncover what lies at the edge of the universe. As we've explored in previous sections, the observable universe is limited by the speed of light and the expansion of space. But what if AI could help us peer beyond this boundary? By analyzing subtle patterns in the cosmic microwave background or detecting faint signals from the earliest moments of the universe, AI might reveal clues about regions of space that are otherwise inaccessible. Some scientists even speculate that AI could help us identify evidence of parallel universes or higher dimensions, pushing the boundaries of what we thought was possible. The integration of AI into cosmic exploration isn't just about technology, it's about collaboration. It's a partnership between human ingenuity and machine precision, where each complements the other's strengths. While AI can process data at incredible speeds, it's human creativity and curiosity that guide its application and interpret its findings. Together, they're opening up new frontiers in our understanding of the universe, from the smallest particles to the largest structures. As we look to the future, the potential of AI in cosmic exploration is boundless. From designing more efficient telescopes to uncovering the secrets of dark energy, this technology is poised to revolutionize how we study the cosmos. And while it's easy to marvel at AI's capabilities, it's important to remember that it's a tool, a powerful one, but still a tool. The real driving force behind our quest to understand the universe remains the same: our insatiable curiosity and our desire to explore the unknown. With AI as our ally, we're not just expanding the boundaries of science, we're redefining what it means to discover the cosmos. The universe is a place of infinite wonder, but how much of it can we truly understand? Our ability to explore and comprehend the cosmos is shaped by the very tools we use: our senses, our instruments, and even our minds. These tools, while extraordinary, have their limits. Our eyes can't see the faintest stars, our ears can't hear the whispers of distant galaxies, and even our most advanced telescopes can only peer so far into the void. The edge of the universe, if it exists, might be a place where the rules of reality stretch beyond what our brains are wired to grasp. Could it be that the cosmos, in all its vastness, holds secrets that are fundamentally beyond human comprehension? To answer this, we need to explore not just the universe, but the nature of perception itself. Human perception is a remarkable but flawed system. Our senses evolved to help us navigate the world around us, not to decode the mysteries of the cosmos. For example, we see only a tiny sliver of the electromagnetic spectrum, visible light, while the universe communicates in a symphony of wavelengths, from radio waves to gamma rays. Even with the aid of technology, we're still filtering the cosmos through the lens of our own limitations. Telescopes and detectors extend our reach, but they're ultimately tools designed and interpreted by human minds, which are shaped by our biology and culture. This means that every observation we make, every discovery we celebrate, is colored by the constraints of how we perceive reality. But what happens when we push these constraints to their limits? Consider the edge of the observable universe. It's not just a physical boundary, it's a perceptual one. Beyond this horizon, light from distant galaxies hasn't had enough time to reach us, meaning those regions are forever out of sight. But even within the observable universe, there are phenomena that challenge our understanding. Black holes, for instance, warp space and time in ways that defy intuition. The singularity at their center, a point of infinite density, is a place where the laws of physics as we know them break down. Can we truly comprehend something that exists beyond the reach of our physical laws, or are these concepts inherently beyond the scope of human thought? This brings us to a profound question. Is the universe designed to be understood, or are there aspects of it that will always remain a mystery? Some scientists argue that the limits of human perception are not just physical but cognitive. Our brains evolved to solve problems on Earth, finding food, building shelters, navigating social dynamics. The cosmos operates on scales and principles so far removed from our everyday experience that they might simply be incompatible with the way our minds are structured. For example, concepts like higher dimensions or the true nature of dark energy might be as incomprehensible to us as calculus is to a goldfish. Yet, even within these limitations, humans have made astonishing progress. We've mapped the cosmic microwave background, detected gravitational waves, and even glimpsed the shadow of a black hole. These achievements are a testament to our ingenuity and determination. But they also highlight the paradox of our quest. The more we learn, the more we realize how much we don't know. The edge of the universe might not just be a physical frontier. It could be a cognitive one, a place where our understanding hits a wall not because the universe is unknowable, but because we're not equipped to know it. This raises an even deeper question. Could consciousness itself play a role in shaping our understanding of the cosmos? Some theories in quantum mechanics suggest that observation affects reality, implying that the act of perceiving the universe might influence its behavior. If this is true, then our perception isn't just a passive window into the cosmos, it's an active participant in its unfolding. This idea blurs the line between observer and observed, suggesting that the universe might not just be something we study, but something we're intrinsically connected to. So, where does this leave us? The limits of human perception remind us that the universe is both a place of discovery and a place of mystery. While we may never fully understand the cosmos in its entirety, the journey to explore it is itself a testament to the power of human curiosity. The edge of the universe might remain a place of wonder, forever just out of reach, but that doesn't diminish the awe we feel when we look up at the stars and dream of what lies beyond. In the end, perhaps the greatest discovery is not the answers we find, but the questions we dare to ask. As we venture into the mysteries of the cosmos, it's easy to focus solely on the scientific tools and theories that drive our exploration. But there's another dimension to this journey, one that doesn't rely on telescopes or equations, but on the power of thought itself. Philosophy, the age-old discipline of questioning and reasoning, has long been a companion to science in the quest to understand the universe. From the ancient Greeks pondering the nature of existence to modern thinkers grappling with the implications of quantum mechanics, philosophy provides a framework for asking the big questions that science alone cannot answer. So, what role does philosophy play in cosmic inquiry? And could the edge of the universe be a place where these two disciplines meet, offering a deeper understanding of reality? At its core, philosophy encourages us to think critically about the nature of existence, consciousness, and the universe itself. While science seeks to explain how things work, philosophy asks why they work that way and what it all means. Take the concept of the multiverse, for example. Science can propose models and theories about parallel universes, but it's philosophy that helps us grapple with the implications. What does it mean for our sense of identity if countless versions of ourselves exist in other realities? How do we define truth or meaning in a cosmos that might be infinite and ever-expanding? These are questions that go beyond data and observation, inviting us to reflect on the deeper significance of what we discover. The interplay between science and philosophy becomes especially fascinating when we consider the edge of the universe. Science provides the tools to explore and measure this boundary, but philosophy helps us interpret what it might represent. Is the edge a physical limit, a perceptual one, or something entirely different? Could it be a threshold where the known meets the unknown, a place where the laws of physics give way to something we can't yet comprehend? These questions push the boundaries of both disciplines, challenging us to think beyond the limits of our current understanding. One of the most profound ways philosophy complements science is by addressing the limits of knowledge itself. Science thrives on evidence and experimentation, but there are questions it can't answer, at least not yet. For instance, what existed before the Big Bang? What lies beyond the observable universe? These are areas where philosophy steps in, offering speculative frameworks and thought experiments that inspire new avenues of scientific inquiry. The famous simulation hypothesis, which suggests that our universe might be a computer simulation, is a perfect example. While it's a philosophical idea at its core, it has sparked serious scientific debate, with researchers exploring ways to test its validity. But philosophy's role isn't just about asking questions, it's also about shaping the way we approach discovery. Ethical considerations, for example, are central to scientific progress. As we develop technologies like artificial intelligence and space exploration, philosophy helps us navigate the moral implications of our actions. Should we attempt to contact extraterrestrial civilizations, what responsibilities do we have to preserve the cosmos for future generations? These are questions that require more than technical expertise. They demand thoughtful reflection on our values and priorities. At the edge of the universe where science and philosophy converge, we're reminded that understanding the cosmos isn't just about uncovering facts, it's about making sense of them. It's about connecting the dots between what we observe and what it means for our place in the grand tapestry of existence. Whether we're pondering the origins of the universe or the nature of consciousness, philosophy provides a lens through which we can explore the deeper dimensions of reality. So, as we stand on the precipice of the unknown, let's not forget the power of thought. The edge of the universe isn't just a frontier for science, it's a space for wonder, curiosity, and reflection. By embracing both the empirical and the philosophical, we can approach the mysteries of the cosmos with a richer, more holistic perspective. And in doing so, we might just discover that the answers we seek are as much about understanding ourselves as they are about understanding the stars. The cosmos has always been a place of wonder, but the future of cosmic exploration promises to take our understanding to unprecedented heights. With cutting-edge technology and ambitious missions on the horizon, we're on the brink of discoveries that could redefine our place in the universe. From next-generation telescopes to interstellar probes, the tools we're developing today could soon unveil secrets hidden at the very edge of the cosmos. So, what's next in our quest to explore the universe? Let's dive into the exciting advancements that are shaping the future of space exploration. At the forefront of this new era is the James Webb Space Telescope, already revolutionizing our view of the cosmos. But the next wave of telescopes promises to push the boundaries even further. Projects like the Nancy Grace Roman Space Telescope, set to launch in the mid-2020s, will map the universe in unprecedented detail, capturing the faintest glimmers of light from the earliest galaxies. These instruments aren't just about sharper images, they're designed to probe the mysteries of dark energy, trace the evolution of galaxies, and even search for signs of life on distant exoplanets. The data they collect could bring us closer to understanding the origins of the universe and its ultimate fate. Meanwhile, ground-based observatories are also undergoing transformative upgrades. The extremely large telescope, currently under construction in Chile, will boast a mirror nearly 40 meters wide, making it the largest optical telescope ever built. With its staggering resolution, it could reveal details of exoplanet atmospheres and uncover clues about the nature of dark matter. These advancements aren't just incremental, they're game changers, offering the potential to answer questions that have puzzled scientists for decades. But telescopes are only part of the story. The future of cosmic exploration also lies in the probes and missions venturing beyond our solar system. NASA's upcoming Europa Clipper mission, for example, aims to study Jupiter's icy moon Europa, which is believed to harbor a vast subsurface ocean. Could this moon be a cradle for extraterrestrial life? Similarly, the Dragonfly mission will send a drone-like rotorcraft to explore Titan, Saturn's largest moon, where lakes of liquid methane and ethane hint at a chemistry that might support life. These missions aren't just about exploring new worlds, they're about redefining what we consider possible in the search for life beyond Earth. Perhaps the most tantalizing possibility lies in the realm of interstellar exploration. Breakthrough Starshot, a visionary project, aims to send tiny, light-powered probes to Alpha Centauri, the nearest star system to Earth. Traveling at a significant fraction of the speed of light, These probes could reach their destination in just a few decades, sending back data from a place no human-made object has ever gone. While the technical challenges are immense, the potential rewards are equally staggering. Imagine receiving images and data from a star system over 4 light-years away, a glimpse into a realm that has long been the stuff of science fiction. Advancements in artificial intelligence are also transforming how we explore the cosmos. AI is being used to analyze vast datasets, identify patterns, and even control spacecraft autonomously. This technology isn't just speeding up discovery, it's enabling us to ask new questions and explore new frontiers. For instance, AI-driven algorithms are helping astronomers sift through the noise of gravitational wave data, uncovering signals that might otherwise go unnoticed. As AI continues to evolve, it could become an indispensable tool in our cosmic toolkit, helping us navigate the complexities of the universe with greater precision and insight. The future of cosmic exploration isn't just about technology, it's about collaboration. International partnerships like those behind the International Space Station and the upcoming Lunar Gateway are paving the way for a new era of shared discovery. By pooling resources and expertise, we're able to tackle challenges that no single nation could overcome alone. This spirit of cooperation extends to private companies as well, with organizations like SpaceX and Blue Origin pushing the boundaries of what's possible in space travel and exploration. As we look to the future, one thing is clear: the edge of the cosmos is no longer a distant, unreachable frontier. With each new mission, each technological breakthrough, we're inching closer to uncovering the secrets of the universe. Whether it's through the lens of a telescope, the sensors of a spacecraft, or the algorithms of an AI, the tools we're developing today are opening up a world of possibilities. The future of cosmic exploration is not just about discovering what lies beyond. It's about reimagining what we thought was possible. And in that journey, the greatest discovery of all might be the limitless potential of human curiosity and ingenuity. The universe is vast, complex, and often defies our intuition, but it's also a canvas for the human imagination. From the earliest stargazers to the scientists of today, our ability to envision the unknown has been just as important as the tools we use to measure it. Imagination isn't just a spark of creativity. It's the driving force behind scientific breakthroughs, helping us ask the right questions and see possibilities where others see limits. Without it, we might never have conceived of black holes, parallel universes, or the Big Bang itself. But what role does imagination play as we peer toward the edge of the cosmos, where the known meets the mysterious? Consider the work of Albert Einstein. His theory of general relativity didn't come from endless equations alone. It emerged from a thought experiment. Einstein imagined what it would be like to ride a beam of light, a leap of creativity that led to one of the most profound understandings of the universe. Similarly, the concept of wormholes, hypothetical shortcuts through spacetime, was born from the imaginative application of mathematics. These ideas weren't just flights of fancy, they were bold, visionary steps that reshaped our understanding of reality. Imagination, in this sense, is the bridge between what we know and what we have yet to discover. But imagination isn't limited to the realm of theoretical physics. It's also essential for interpreting the data we collect. Take the cosmic microwave background, the afterglow of the Big Bang. To the untrained eye, it's a faint, static-filled map of the sky. But through the lens of imagination, scientists see the echoes of the universe's birth, a story written in the faint ripples of radiation. It's this ability to connect the dots, to see patterns and possibilities, that turns raw data into meaningful discovery. Without imagination, the universe would remain a collection of numbers and signals, devoid of context or narrative. Now, let's turn our gaze to the edge of the cosmos. What lies beyond the observable universe? Is it an infinite void, a multiverse, or something we can't yet conceive? These questions push the boundaries of both science and imagination. While telescopes and equations can take us only so far, it's our ability to dream, to hypothesize, that propels us forward. Some of the most exciting theories, like the idea that our universe is just one bubble in a vast cosmic foam, are rooted in imaginative leaps that challenge our understanding of reality. The edge of the cosmos, then, isn't just a physical boundary, it's a frontier of thought where the limits of our knowledge meet the limitless potential of the human mind. Yet, imagination isn't without its pitfalls. It's easy to get carried away by speculative ideas, to mistake creativity for certainty. That's where science steps in, providing a framework to test and refine our ideas. Imagination proposes, but experimentation disposes. The interplay between creativity and rigor is what makes scientific discovery so powerful. It's a dance between dreaming big and grounding those dreams in evidence, ensuring that our vision of the cosmos remains both bold and accurate. So, as we ponder the mysteries of the universe, let's not underestimate the role of imagination. It's the spark that ignites curiosity, the lens through which we interpret the unknown, and the tool that allows us to envision what lies beyond the edge of our understanding. Whether we're exploring the depths of a black hole or the farthest reaches of space, imagination reminds us that the universe isn't just a place to study. It's a story to be imagined, a puzzle to be solved, and a mystery to be embraced. And as we continue to explore, we're not just uncovering the secrets of the cosmos, we're discovering the limitless potential of the human spirit. As we venture further into the cosmos, our journey isn't just about discovery, it's also about responsibility. The ethical implications of cosmic exploration are profound, raising questions that challenge our values, priorities, and even our identity as a species. What happens if we encounter extraterrestrial life? Should we alter the universe's structure to suit our needs? These aren't just hypothetical scenarios, they're real dilemmas that could define humanity's future as we push toward the edge of the cosmos. One of the most pressing ethical questions is how we should approach the potential discovery of extraterrestrial life. Imagine a scenario where our telescopes detect unmistakable signs of life on a distant exoplanet. Should we attempt to make contact, or would that be an intrusion? Philosophers and scientists alike have debated this issue for decades, with some arguing that reaching out could lead to unprecedented cooperation and knowledge sharing, while others warn of the risks of unintended consequences. What if our actions inadvertently harm an alien civilization, or worse, provoke hostility? The stakes are high, and the decisions we make could ripple across the universe. But the ethical challenges don't end with first contact. Even if we never encounter intelligent life, the mere act of exploring and altering the cosmos raises moral questions. For instance, consider the idea of transforming another planet to make it habitable for humans. While this might seem like a practical solution to overpopulation or climate change, it also raises concerns about the potential destruction of indigenous ecosystems, even if they're microbial. Do we have the right to reshape another world, or should we preserve it as a cosmic sanctuary, untouched by human influence? These questions force us to confront our role as stewards of the universe, not just its explorers. The edge of the cosmos adds another layer of complexity to these ethical dilemmas. What if our exploration uncovers phenomena that challenge the very fabric of reality as we know it? For example, if we were to discover a region of space where the laws of physics behave differently, should we attempt to study and harness it, or leave it undisturbed? The temptation to exploit such discoveries for technological advancement or energy resources could be overwhelming, but doing so might have unforeseen consequences. The edge of the universe might not just be a physical frontier, it could also be an ethical one where the rules we follow here on Earth no longer apply. Another ethical consideration is the impact of our exploration on future generations. The technologies we develop today, from powerful telescopes to interstellar probes, will shape the way humanity interacts with the cosmos for centuries to come. Are we building a legacy of curiosity and stewardship, or one of exploitation and dominance? The choices we make now will determine whether the universe becomes a place of collaboration and wonder or a battleground for resources and power. It's a responsibility that extends far beyond our lifetime, requiring us to think not just about what we can do, but what we should do. At the heart of these ethical questions is a deeper issue: how we define our place in the universe. Are we merely temporary inhabitants of a vast, indifferent cosmos, or do we have a duty to act as caretakers, preserving its beauty and complexity for future explorers? The answers aren't clear-cut, but they're essential to shaping the future of cosmic exploration. As we stand on the precipice of the unknown, we're not just discovering new worlds, we're defining who we are and what we stand for. The ethical implications of cosmic exploration remind us that the universe isn't just a place to conquer, it's a space to reflect, to question, and to grow. Whether we're contemplating the fate of distant worlds or the impact of our actions on the cosmos, these dilemmas force us to confront the values that guide us. And as we continue to explore, we're not just uncovering the mysteries of the universe, we're uncovering the essence of humanity itself. The universe is vast, but our ability to explore it is amplified when we work together. Cosmic exploration isn't just the domain of a single nation, culture, or discipline. It's a shared human endeavor that thrives on collaboration. From the engineers designing cutting-edge telescopes to the astrophysicists interpreting the data they collect, every discovery is the result of countless minds working in unison. This spirit of teamwork isn't just a practical necessity. It's a testament to what humanity can achieve when we unite in pursuit of a common goal. Take, for example, the International Space Station, a marvel of human ingenuity and cooperation. Built through the combined efforts of space agencies from around the world, it's a symbol of what's possible when we set aside boundaries and focus on the bigger picture. Astronauts from different nations live and work together in orbit, conducting experiments that benefit all of humanity. It's a reminder that the cosmos doesn't belong to any one country or group. It's a frontier that invites us all to explore, learn, and grow. But collaboration in cosmic exploration goes beyond just space agencies. Universities, research institutions, and even amateur astronomers play vital roles in advancing our understanding of the universe. Citizen science projects, where everyday people contribute to data analysis or observations, have led to groundbreaking discoveries, from identifying new exoplanets to tracking asteroids. These efforts show that the pursuit of knowledge isn't limited to experts in lab coats. It's a shared journey that anyone can be a part of. This collective approach is especially crucial as we push toward the edge of the cosmos. Exploring the farthest reaches of the universe requires resources, expertise, and perspectives that no single entity can provide alone. Massive projects like the Event Horizon Telescope, which captured the first image of a black hole, involved hundreds of scientists and observatories across the globe. Without this level of collaboration, such a feat would have been impossible. The edge of the universe, then, isn't just a scientific frontier. It's a place where humanity's collective effort becomes our greatest strength. The importance of collaboration also extends to cultural and philosophical perspectives. Different cultures bring unique ways of understanding and interpreting the cosmos, enriching our collective knowledge. For instance, indigenous astronomers offer insights into the stars and planets that complement modern scientific discoveries. By integrating these diverse viewpoints, we gain a more holistic understanding of the universe, one that reflects the richness of human experience. Yet, collaboration isn't without its challenges. Coordinating efforts across borders, languages, and disciplines requires patience, trust, and a willingness to listen. But these challenges are outweighed by the rewards. When we work together, we not only accelerate scientific progress, but also foster a sense of shared purpose that transcends our differences. The cosmos, in all its grandeur, reminds us that we're part of something much larger than ourselves, a single species on a tiny planet, reaching out to explore the infinite. As we gaze toward the edge of the universe, we're reminded that the journey isn't just about uncovering the mysteries of space. It's about discovering what we can achieve together. Whether it's through international partnerships, interdisciplinary research, or community-driven projects, collaboration is the key to unlocking the secrets of the cosmos. And in that shared pursuit, we find not just answers, but a deeper connection to each other and the universe we call home. Curiosity has always been the spark that ignites our journey into the unknown. It's what compels us to look up at the night sky and wonder what lies beyond the stars. From the earliest astronomers charting the heavens to modern scientists probing the edges of the observable universe, curiosity is the thread that weaves through every discovery, every breakthrough, and every question we dare to ask. But what is it about this deep-seated drive to explore that propels us forward, even when the answers seem out of reach? And how does this unrelenting curiosity shape our understanding of the cosmos, especially as we approach its mysterious edge? At its core, curiosity is more than just a desire to know. It's a fundamental part of what makes us human. It's the force that pushed early explorers to venture beyond familiar horizons, and it's the same force that drives us to build telescopes, launch probes, and dream of interstellar travel. When we peer into the depths of space, we're not just seeking answers to scientific questions, we're fulfilling a primal urge to understand our place in the universe. This connection between curiosity and exploration is what makes cosmic discovery so deeply personal. It's not just about uncovering facts, it's about connecting with something greater than ourselves. But curiosity isn't just a passive observer, it's an active participant in the process of discovery. It pushes us to ask questions that challenge our assumptions and to think creatively about problems that seem insurmountable. Take the concept of dark energy, for example. When scientists first observed that the universe's expansion was accelerating, it was curiosity that drove them to explore this unexpected phenomenon. They didn't just accept the data at face value, they asked why. Why is the universe behaving this way? What does it mean for our understanding of space and time? These questions, born of curiosity, have led to some of the most profound insights in modern cosmology. Now, let's consider the edge of the cosmos. What role does curiosity play as we approach this elusive boundary? In many ways, the edge represents the ultimate frontier, a place where our knowledge ends and the unknown begins. It's a realm that defies easy answers, where the familiar laws of physics might no longer apply. Yet, it's precisely this uncertainty that fuels our curiosity. The edge of the universe isn't just a physical limit, it's a challenge to our imagination, a call to explore beyond what we can see and measure. Could it be that the greatest discoveries lie not in the answers we find, but in the questions we dare to ask? Curiosity also reminds us that exploration isn't just about reaching a destination, it's about the journey itself. Every observation, every experiment, every theory is a step along the path of discovery. And as we push toward the edge of the cosmos, we're reminded that the pursuit of knowledge is as much about the process as it is about the outcome. It's about embracing the unknown, celebrating the unexpected, and finding wonder in the mysteries that remain. So, what does the future hold for our curious exploration of the universe? As technology advances and our tools become more sophisticated, our ability to probe the cosmos will only grow. But it's our curiosity that will continue to drive us forward, inspiring new questions, new ideas, and new ways of understanding the universe. Whether we're studying the birth of stars, the nature of dark matter, or the mysteries of the cosmic horizon, curiosity will always be our guiding light, a reminder that the universe is not just a place to explore, but a story to be discovered one question at a time. Technology has always been the bridge between humanity and the cosmos, transforming the way we see and understand the universe. From the first rudimentary telescopes that Galileo pointed at the heavens to the sophisticated instruments we use today, each advancement has opened new windows into the vast expanse of space. But what makes technology so transformative isn't just its ability to magnify distant stars, it's how it reshapes our perception of reality itself. As we push the boundaries of cosmic exploration, the tools we design are not just extensions of our senses, they're keys to unlocking mysteries that once seemed beyond our reach. Consider the evolution of telescopes, for instance. The Hubble Space Telescope, launched in 1990, revolutionized our understanding of the cosmos by capturing images of galaxies billions of light-years away. But its successor, the James Webb Space Telescope, takes this even further. With its infrared capabilities, Webb peers through cosmic dust to reveal the birth of stars and galaxies in the early universe. These telescopes aren't just tools, they're time machines, allowing us to glimpse the universe as it was billions of years ago. And as technology continues to evolve, so too does our ability to explore the farthest reaches of space, bringing us closer to the edge of the observable universe than ever before. Yet telescopes are just one piece of the puzzle. Space probes like Voyager 1 and 2, which have ventured beyond our solar system, carry with them the hopes and dreams of humanity. These robotic explorers send back data from the outer edges of our cosmic neighborhood, offering insights into the conditions of interstellar space. Meanwhile, missions like the Parker Solar Probe dive into the sun's scorching atmosphere, unraveling the mysteries of our star. Each of these missions is a testament to human ingenuity, proving that the limits of exploration are not defined by our physical reach, but by the tools we create to extend it. But what about the edge of the cosmos? Could technology reveal dimensions of reality that we can't yet comprehend? Some of the most exciting possibilities lie in the realm of quantum computing and AI. Quantum computers, with their ability to process vast amounts of data simultaneously, could one day simulate the conditions of the early universe or model the behavior of black holes in ways that classical computers cannot. Similarly, artificial intelligence is already transforming how we analyze astronomical data, sifting through terabytes of information to identify patterns and anomalies that might otherwise go unnoticed. These technologies aren't just enhancing our ability to explore, they're redefining what it means to discover. The role of technology in cosmic exploration goes beyond mere observation. It's about reshaping our understanding of the universe. Gravitational wave detectors like LIGO have opened an entirely new way of listening to the cosmos, capturing ripples in space-time caused by cataclysmic events like colliding black holes. This groundbreaking technology has given us a new lens through which to view the universe, one that complements traditional telescopes and probes. It's a reminder that the cosmos speaks in many languages, and technology is our interpreter. As we stand on the cusp of new discoveries, it's clear that the tools we create are as much a part of the journey as the destinations they help us reach. From the depths of quantum mechanics to the farthest edges of space, technology is the thread that connects us to the mysteries of the universe. And while the edge of the cosmos may remain shrouded in mystery, one thing is certain: the innovations we develop today will light the way to the discoveries of tomorrow. The universe is vast, but with each technological leap, it becomes a little less unknown. Imagine a classroom where students aren't just learning about the planets and stars, but are actively dreaming about exploring them. This is the power of education. It doesn't just teach facts, it ignites curiosity and fuels the imagination. By introducing young minds to the wonders of the cosmos, we're not just preparing them for careers in science or engineering, we're inspiring them to ask the big questions that drive humanity forward. What lies beyond our solar system? How did the universe begin? And perhaps most intriguingly, what might we discover at the edge of the cosmos? These are the questions that education encourages, planting the seeds for future breakthroughs. Education in astronomy and space science has a unique ability to bridge disciplines, blending physics, mathematics, biology, and even philosophy. When students learn about black holes, they're not just memorizing facts about gravity, they're grappling with concepts that challenge our understanding of reality. When they study the life cycle of stars, they're exploring the origins of the elements that make up everything around us, including themselves. This interdisciplinary approach doesn't just build knowledge, it fosters creativity and problem-solving skills, traits that are essential for the next generation of explorers. But it's not just about the science. Education also plays a crucial role in shaping the values that guide cosmic exploration. Teaching about the universe encourages humility, reminding us of our small place in the vastness of space. At the same time, it inspires ambition, showing students that even the most distant stars are within the reach of human ingenuity. This balance of humility and ambition is what drives innovation, pushing us to develop new technologies and explore uncharted territories. The classroom becomes a launching pad, not just for rockets, but for ideas that could one day redefine our understanding of the cosmos. The role of educators in this process cannot be overstated. A passionate teacher can transform a simple lesson about the solar system into a lifelong fascination with space. By using hands-on activities like building model rockets or analyzing real astronomical data, educators can make the cosmos feel tangible and exciting. Programs like NAS, a student launch initiative, or citizen science projects allow students to contribute to real-world research, giving them a sense of ownership and pride in their work. These experiences don't just teach, they inspire, showing students that they too can be part of humanity's journey to the stars. Looking ahead, the edge of the cosmos represents both a challenge and an opportunity for future generations. Could the mysteries of this boundary, whether it's the nature of dark energy, the possibility of parallel universes, or the origins of space-time itself, be unlocked by young minds inspired by their education? The answer lies in the classrooms of today, where curiosity is nurtured and dreams are encouraged. By investing in education, we're not just preparing students for the future, we're ensuring that the spirit of exploration continues to thrive, pushing humanity toward new horizons. Ultimately, education is more than a tool for learning. It's a catalyst for discovery. It's the spark that turns a child's fascination with the night sky into a lifelong quest for knowledge. And as we stand on the precipice of new cosmic frontiers, it's clear that the seeds of tomorrow's breakthroughs are being planted today, in the minds of students who dare to dream of what lies beyond. The edge of the cosmos may be vast and mysterious, but with the right education, it's a frontier that future generations will be ready to explore. Art has always been a mirror to humanity's deepest questions, and nowhere is this more evident than in our attempts to interpret the cosmos. For centuries, artists have translated the wonders of the night sky into breathtaking works of imagination, from the starry swirls of Van Gogh's Starry Night to the celestial geometries of Islamic art. But what happens when art and science come together, not just as parallel pursuits, but as collaborators in the quest to understand the universe? Could the edge of the cosmos be a place where these two disciplines merge, offering fresh perspectives on the mysteries that lie beyond? One of the most striking examples of this collaboration is the visualization of concepts that defy easy explanation. Take black holes, for instance, these enigmatic objects where gravity becomes so intense that not even light can escape are almost impossible to depict accurately. Yet, artists and scientists have worked together to create renderings that capture their essence, from the swirling accretion disks to the mind-bending distortions of space-time. These visualizations aren't just beautiful, they're tools for understanding. By translating complex scientific ideas into images, art helps bridge the gap between abstract theory and tangible reality, making the cosmos more accessible to everyone. But the role of art goes beyond mere representation. It's also a medium for exploring the emotional and philosophical dimensions of the universe. When we gaze at the edge of the cosmos, we're not just looking at a physical boundary, we're confronting the limits of human understanding. Artists, with their ability to evoke wonder and curiosity, help us grapple with these profound questions. What does it mean to exist in a universe that may be infinite? How do we reconcile our smallness with the vastness of space? These are questions that science can frame, but art can feel, offering a visceral connection to the mysteries that words and equations alone cannot convey. The intersection of art and science also opens up new ways of thinking about the cosmos. Consider the concept of the multiverse. While scientists use mathematics and physics to explore the idea of parallel universes, artists imagine what these worlds might look like. Through paintings, films, and digital art, they bring to life the infinite possibilities of existence, from alternate realities to entirely different laws of physics. These creative explorations don't just complement scientific inquiry, they challenge it, pushing us to consider ideas that might otherwise seem too abstract or speculative. Perhaps the most exciting aspect of this fusion is its potential to inspire. Art has the unique ability to spark curiosity and ignite the imagination, qualities that are essential for scientific discovery. When we see a vivid depiction of a distant galaxy or a haunting portrayal of the universe's birth, we're not just observing, we're connecting. These images remind us that the cosmos isn't just a collection of data points. It's a story, a living tapestry of wonder and mystery. And in that story, art and science are not separate threads but intertwined strands, each enriching the other. As we stand on the precipice of new discoveries, the role of art in interpreting the cosmos becomes more important than ever. The edge of the universe, with its tantalizing mysteries, invites us to explore not just with our minds but with our hearts. By embracing the fusion of creativity and inquiry, we can approach the cosmos with a deeper sense of wonder and a greater appreciation for its infinite complexity. Whether through the brushstrokes of a painting or the equations of a theory, the journey to understand the universe is as much about feeling as it is about knowing. And in that journey, art and science are our most faithful companions, guiding us toward the truths that lie just beyond the edge of our understanding. As we bring this cosmic exploration to a close, it's impossible not to feel a sense of awe at the vastness and complexity of the universe. The edge of the cosmos, with its tantalizing mysteries and unanswered questions, reminds us how much we've yet to learn. From the invisible grip of dark energy shaping the universe's expansion to the mind-bending concept of parallel realities, each discovery and each unanswered question pushes the boundaries of what we thought was possible. These ideas don't just challenge our understanding of space and time, they invite us to reimagine the very fabric of existence. What makes this journey so remarkable isn't just the scale of the universe or the depth of its secrets, it's our relentless drive to uncover them. Every theory, every observation, and every experiment is a step toward understanding a cosmos that is both beautiful and bewildering. The edge of the universe may remain shrouded in mystery, but it's that very mystery that fuels our curiosity and propels us forward. It's a reminder that the universe isn't just a place to explore, it's a story to be told, one discovery at a time. And while we may not have all the answers yet, the pursuit itself is a testament to the power of human ingenuity and imagination. Whether it's through groundbreaking technology, collaborative science, or the simple act of looking up at the night sky, we're constantly reminded of our connection to something greater than ourselves. The cosmos isn't just out there, it's within us, shaping our questions, our dreams, and our sense of wonder. So, as we conclude this journey, let's not forget that the universe is always evolving, and so are we. Each new discovery brings us closer to understanding the cosmos, but it also opens the door to even more questions. That's the beauty of exploration, it's never truly finished. The edge of the universe may be a frontier, but it's also an invitation to keep exploring, keep questioning, and keep dreaming. Thank you for joining us on this incredible adventure through the mysteries of the cosmos. If you enjoyed this journey, don't forget to like, subscribe, and share your thoughts in the comments below. The universe is full of surprises, and who knows? The next big discovery might be just around the corner. Until then, keep looking up because the stars have so